Have you ever wondered why some projects seem to be in a state of constant legal battle while others flow smoothly from inception to handover? Often the difference isn't the quality of the engineering, but the strategy behind the contract. Welcome to Lecture 13 of your Construction Professional Certification Prep. Today, we are diving deep into contract life cycle strategy and management. This isn't just about reading the fine print after a problem occurs. Professional contract management is a continuous circular process, just like the diagram you see here. It starts long before a shovel hits the ground and continues long after the ribbon is cut. In the world of the PMI-CP exam, understanding this cycle is the key to transitioning from a traditional project manager to a strategic construction leader. First, we will look at how the contract lifecycle integrates with your daily operations. Next, we will explore why a strategy-first approach is essential for protecting your project's margin and your organization's reputation. This matters because a contract is more than a legal shield. It is the roadmap for the entire project delivery. By the end of this session, you'll see the contract not as a static document sitting in a drawer, but as a dynamic tool that guides every decision you make. Now let's look at exactly what the exam expects you to master in this module. What is the most critical next step when a client suddenly changes the project scope? If you aren't sure, the PMI-CP exam will likely catch you off guard. Our objectives today are strictly aligned with the exam's focus on identifying the correct sequence of actions in a project's life. First, we are going to learn how to differentiate between the 5 fundamental stages of a contract: discovery, pre-award, proposal, execution, and closeout. You'll need to know exactly which stage you are in to make the right choice. We'll also tackle a high-level concept, the walkaway point. This is the threshold where the risk simply isn't worth the reward. For an engineer or PM, knowing when to say no is just as important as knowing how to build. Next, we will break down the technical differences between a request for tender, RFT, and a request for proposal, RFP. This selection depends entirely on design maturity, essentially how finished your drawings are before you go to market. We will also look at linguistic precision. In the legal world, words like must and may are worlds apart. One is a mandatory obligation, while the other is a discretionary right. Finally, we'll focus on the governance of change management. The exam specifically tests your ability to resolve disputes by adhering to strict contract clauses and distinguishing between risk allocation, who owns the risk, and risk mitigation, how we reduce it. This foundation will prepare you for the complex scenarios you'll face on exam day. Let's start by visualizing the entire framework. Imagine building a skyscraper without a foundation. That is exactly what it's like to manage a project without a structured contract framework. As we look at this 5-stage model, notice the note at the bottom. This cycle runs parallel to the project delivery cycle. They are intertwined, but they focus on different things. We begin with stage 1, discovery. This is the "is this a good idea" phase. We look at feasibility and build a business case. Stage 2 is pre-award, where we decide our strategy. Are we doing design build or a traditional method? We also prepare our risk documentation here. Stage 3 is the proposal process. This is where the market gets involved through solicitation, bidding, and our evaluation of those bids. Once a winner is selected, we move into stage 4, execution and management. This is the meat of the project where we track performance and manage changes through strict governance. Finally, we reach stage 5, contract closeout. This is often the most neglected phase, but it is where we handle handovers, warranties, and that all-important final payment. This matters because if you skip a step, for example, if you go to the proposal stage before you've finished your risk documentation and pre-award, you are walking into a trap. Each stage provides the necessary information for the one that follows. Now, let's zoom in on stage 1 and talk about the point where you might decide to walk away entirely. What is the most expensive project your company could ever take on? Often, it's the one you should have never bid on in the first place. This is where stage 1, discovery, comes in. It's a period of intense screening and feasibility analysis to ensure a project aligns with your strategic goals. If you are an owner, your focus here is on the business case. You're asking about return on investment, ROI, and benchmarking the project against the current market to see if it's realistic. If you are a contractor, you are screening the opportunity. You're looking at the client, the location, and the technical requirements to see if they fit your expertise. Now look at the graph on the slide. This represents one of the most critical exam concepts, the walkaway point. As the project phase moves forward, the risk level typically increases while the margin or potential profit might stay flat or even decrease. The threshold is a horizontal line representing your company's maximum risk tolerance. The red X is the walkaway point. You must define this point before you commit capital. Ask yourself, is the complexity beyond our current capability? Is the profit margin large enough to cover the what-ifs? If the risk line crosses your threshold, the professional move is to walk away. This isn't a failure, it's a governance rule that protects the firm. To see how this works in a real scenario, let's look at a discovery phase problem. Let's put you in the hot seat. You are a director at a construction firm looking at a massive mega project. During the discovery phase, you find 2 red flags. The client doesn't have a clear funding structure yet, and the site has unmapped geological risks. To make things harder, your firm is already highly leveraged, meaning you don't have much cash or bonding capacity to spare. What is your next move? The exam will give you choices that sound reasonable. You could increase your bid margin, option 1, to cover the risks, but you might still lose a lot of money if the project stalls. You could submit a qualified bid, option 3, but the client might throw it out. You could wait for the RFP, option 4, but that's being reactive. The best action is option 2. Offer a short-term feasibility study contract. Why? Because the PMI-CP values risk-based decision-making. By taking a small, separate contract to do the due diligence, you get paid to investigate the geological risks and wait for the funding to materialize. You aren't committing your whole firm to a billion-dollar risk. You're taking a calculated, professional step to gather more data. This rationale, protecting capital while seeking information, is a recurring theme in the exam. Once you have the information and decide the project is a go, you move to stage 2 to set your procurement strategy. Once the project passes the discovery phase, we enter stage 2, pre-award strategy. This is where we set the rules of engagement for the contract. This stage is built on 3 pillars. First is the delivery method. Are we going with design bid build, DBB, where the design is 100% done? Design build, DB, where one entity does both. Or maybe integrated project delivery, IPD, where everyone shares the risk. This decision is huge because it dictates exactly how the contract will be structured. Second is risk documentation. Before you ever ask a contractor for a price, you must document your risk appetite. What risks are you willing to take, and what risks do you want to transfer to the contractor? This must be written down before tendering begins. Third is the evaluation criteria. To be a professional, you need a rigorous scorecard. You shouldn't just pick the cheapest guy. You need to look at financial stability, their past performance, and their safety record, specifically their experience modification rate, or EMR. If a contractor has a bad EMR, they might be a huge liability on your site. The goal here is objectivity. You want a system that picks the best partner based on facts, not feelings. One of the most important decisions in this stage is whether to use an RFT or an RFP, and the exam has a very specific logic for this. Voice-over script. This slide is a cheat sheet for a guaranteed exam question. You need to know when to use a request for tender, RFT, versus a request for proposal, RFP. The deciding factor is design maturity. Imagine you are an owner. If your design maturity is high, meaning you have 100% complete blueprints, you use an RFT, you know exactly what you want, and you're asking suppliers to price this specific work. Your focus is on who can give you the best cost and follow the schedule most strictly. However, if your design maturity is low, meaning you just have a concept or a functional requirement, you use an RFP. You know the outcome you want, like, I need a bridge that carries 5,000 cars. But you don't know the best way to build it. You are asking the supplier to propose a solution. Here, you are paying for their innovation and their specific methodology. For the exam, look for keywords. If the scenario says the drawings are complete, that is a signal for RFT. If it says the owner is seeking alternative solutions or innovation, that is a signal for RFP. Getting this strategy right ensures that the next stage, the proposal process, is fair and effective. Stage 3 is the proposal process, where the project moves from your internal team to the open market. This process follows a very specific order: solicitation, an RFI, request for information period, submission, selection, and finally, contract formulation. The most important governance rule for the exam involves the RFI period. Let's say bidder A finds a mistake in your drawings and asks for clarification. If you only tell bidder A the answer, you've created information asymmetry. That is an unfair advantage, and it can lead to a bid protest that shuts down your project. The rule is, if you answer an RFI for one bidder, you must issue a formal addendum to every single bidder. When it comes to selection, professional PMs avoid the low bid trap. We've all seen it. A contractor bids extremely low just to get the job, but then they have no margin left to actually do the work safely or on time. Instead, you should select based on best value. Best value is a calculation that weights the price against other factors, like the contractor's safety record, their financial health, and their current capacity. You want to know, do they have the people available right now to actually finish my project? Once you've selected the right partner and formulated the contract, it's time to move into execution. We are now in stage 4, execution. This is where most projects succeed or fail, based on how well the contract is managed on a daily basis. Here's a practical reality. Your field supervisors and site engineers are probably not going to read a 200-page legal contract every morning. To bridge the gap between the legal office and the construction site, we use a laminated list, or a project cheat sheet. This is a one-page summary of the most critical notice provisions. For example, if the contract says a delay notice must be filed within 48 hours of an event, that needs to be on this list. You also want your safety protocols, scope boundaries, and major milestones clearly visible. You should post this in meeting rooms and common areas. Why? Because it enforces contractual awareness. If a site supervisor knows they only have 48 hours to report a problem, they are much more likely to pick up the phone. This prevents a small technical issue on site from becoming a massive legal dispute 6 months later because no one gave proper notice. Execution is all about following the rules of the game. And the most important rule of the game is knowing who actually has the power to change those rules. This is what we call governance. The client told me to just go ahead and move that wall, so I did. Those are some of the most dangerous words in construction. In stage 4, clear governance and change authority are your only defense against unauthorized scope creep. Every professional project should have delegated authority limits. As you see on the slide, a sponsor or owner might handle big changes over $50,000. A project manager might have authority for smaller changes. But look at the field supervisor. They have site execution only authority. They cannot, and should not, approve a change to the scope. The change control process must be a formal loop. You review the change, You approve it in writing, and you track its impact on the budget and schedule. There is no room for handshake deals. Here is a major exam tip. If a scenario describes a client giving a verbal instruction to a PM to change something, the correct action is never to just start the work. The correct action is to halt, document the request, and follow the formal change process. To do this effectively, you need to understand the specific language used in the contract clauses. In the world of contracts, words are like surgical tools. They must be used with precision. One of the most common causes of disputes is a misunderstanding of linguistic precision. If a clause says must or shall, it is a mandatory obligation. If you don't do it, you are in breach of contract. However, if it says may, it is discretionary. You have the right to act, but you aren't forced to. For example, the owner may inspect the work, means they can if they want to, but they don't have to. You also need to master the key clauses. Termination for cause means someone messed up, a default, whereas convenience means the owner can end the project for no reason at all, though they usually have to pay a fee. Indemnity is all about risk transfer. Who pays if a third party gets hurt? Liquidated damages are pre-agreed amounts paid if the project is late. They aren't penalties, they are compensatory. Finally, look at the dispute resolution ladder. You always start with negotiation. If that fails, you go to arbitration, a private judge. Only as a last resort do you go to litigation, public court. Understanding these clauses is what allows you to handle a delay claim without panicking. Let's look at a scenario that happens on almost every project. A contractor submits a claim for a 2-week extension because of unusually severe weather. The owner sends a quick email rejecting it, and now the contractor is threatening to stop work. What do? The exam will try to tempt you with soft answers. You might want to compromise, option 4, to keep the project moving, or you might want to escalate to arbitration immediately, option 3. But the best action is option 2. Review the force majeure and notice clauses for validity. Why? Because in contract management, contract adherence comes first. You need to check, does the contract actually define rain as a force majeure event? More importantly, did the contractor give timely notice? If the contract requires notice within 48 hours of the storm, and they waited 2 weeks, the claim is legally dead before it even starts. By sticking to the contract, you remove the emotion from the argument. It's not about being mean, it's about following the rules everyone agreed to. If the claim is valid, you grant it. If not, you have a solid basis for rejection. This leads us to our final stage, closeout. We are at the finish line. Stage 5, contract closeout. Many project managers make the mistake of thinking the project is done when the building is standing. But as the slide says, the project is not complete until the contract is closed. This is often the most neglected stage because everyone is tired and wants to go home. Closeout involves 4 major tasks. First is the punch list, or snag list. This is a final walkthrough to find every small defect, a scratched tile, a leaky faucet, and fix it. Second is the documentation handover. You must hand over the operation and maintenance O&M manuals, the warranties, and the as-built drawings that show where everything was actually installed. Third is final accounting. This is where you settle all outstanding change orders and finally release the retainage, or final payment. Fourth, and most importantly for your organization's future, is lessons learned. Did the contractor perform well? Were there clauses that caused too much friction? If you don't close the contract properly, you leave your company open to tail-end risks, like warranty disputes or unpaid claims that pop up years later. To avoid these headaches, let's look at the most common pitfalls you'll encounter. As we near the end of the module, let's talk about why projects fail. These 5 pitfalls are the monsters under the bed for every contract manager. Number 1 is poor scope definition. If the contract doesn't clearly say what is not included, you are going to have a dispute. Number 2 is ambiguous language. If you use shall when you mean may, or use vague words like reasonable, you are inviting a lawyer to argue with you. Number 3 is deal fever. This is when a company is so desperate to win a job that they ignore their own walkaway point. They take on a project with a risk profile that they simply cannot handle. Number 4 is the failure to track changes. This happens when you have handshake deals on site but no formal paperwork. Eventually, the money runs out and no one knows who owes what. Finally, number 5, siloed teams. This is when the legal department writes the contract, but the project manager never reads it. If the people building the project don't understand their legal obligations, the contract is just a piece of paper. To wrap up, let's look at the mindset you need to succeed. We've covered a lot of ground today. To succeed on the PMI-CP exam and in your career, you need to adopt the contract manager's mindset. First, be proactive. Do not wait for a crisis to read your contract. You should know your notice periods and your musts before day 1. Second, be structured. Use the 5-stage framework we discussed. Discovery, pre-award, proposal, execution, and closeout. Each stage has a job to do. Third, be governance-driven. Respect the limits of authority. If you aren't authorized to sign for a 100K change, don't do it. Always insist on written notice. Fourth, be risk-aware. Use the walkaway point to protect your organization. No single project is worth risking the entire firm's stability. Remember, a well-managed contract isn't just a legal document. It is the roadmap to project success. It ensures that everyone knows their role, their risks, and their rewards. Welcome to Lecture 14 of the PMI-CP exam preparation series. Today we are diving deep into the world of contract life cycles, obligations, governance, and risk management. This isn't just about reading the fine print. It's about understanding the framework that keeps a project structurally sound from the first spark of an idea to the final closeout. Think of a contract as the skeleton of your project. If the bones are weak or misaligned, the entire body, no matter how well trained the muscles are, will eventually fail under pressure. In the built environment, where stakeholders range from owners and designers to specialized contractors and equipment suppliers, the complexity is immense. We need a strategy to navigate these relationships. This lecture is designed to move you beyond a basic understanding of signing a deal and into a sophisticated mastery of how governance and risk management drive successful project outcomes. We will begin by breaking down the 5 distinct stages of the contract lifecycle. We will explore how to establish governance that actually works, ensuring that decision-making authority is clear and compliance is more than just a checkbox. Furthermore, we will analyze the specific language that can make or break a project, those subtle shifts between must and may that carry heavy legal and financial weight. By the end of this session, you will be equipped to handle the high-pressure, scenario-based questions you'll encounter on the PMI-CP exam, specifically those involving risk allocation and dispute resolution. As we move forward, keep in mind that a contract is a living document. It evolves, it requires active management, and it demands constant vigilance. Let's start by setting our sights on the specific learning objectives we aim to conquer today. Before we dive into the mechanics of contracting, we need a clear roadmap for what we intend to achieve. Our first objective is to map the entire contract lifecycle. You aren't just memorizing names, you are mastering the 5 distinct stages: discovery, pre-award, proposal process, execution and management, and finally, contract closeout. Each of these stages involves critical activities that, if missed, can derail a project months or even years down the line. For example, failing to properly handle the discovery phase often leads to scope creep during execution because the original business case wasn't solid. Our second objective focuses on the power of words. In the built environment, contract language is your primary tool for risk management. We are going to differentiate between mandatory language, words like must or shall, and discretionary language, such as may. This might sound like a minor linguistic detail, but in a court of law or a dispute resolution board, it is the difference between a breach of contract and a valid exercise of professional judgment. We will also learn to spot high-risk clauses that are notorious for causing friction in construction projects. Thirdly, we will look at governance. It is one thing to have a signed contract. It is another thing entirely to ensure that the project is executed according to that contract. Governance defines who has the authority to make decisions. If a site engineer approves a change order without the delegated authority from the owner, you have a process failure that could lead to non-payment or legal challenges. Understanding how compliance drives execution is vital for any project professional. Finally, all of this theory must be applied. The PMI-CP exam is famous for its scenario-based questions. We will practice applying best practices to solve complex problems regarding risk allocation, tendering strategies, and disputes. By the time we finish, you won't just know the definitions, you'll know how to act when a project hits a snag. To start this journey, let's clarify a common point of confusion: the difference between the project lifecycle and the contract lifecycle. A common mistake many project managers make is treating the project lifecycle and the contract lifecycle as the same thing. They are related, certainly, and they run in parallel until commissioning, but they are fundamentally distinct. Imagine the project lifecycle as the what and the how of building, the design, the construction, the testing. The contract lifecycle is the who and the under what terms. It is the legal and commercial heartbeat that pumps the resources into the project. The contract lifecycle consists of 5 stages: discovery, pre-award, the proposal process, execution and management, and contract closeout. Each of these stages has its own rhythm and requirements. For the PMI-CP exam, you must realize that a single project rarely has just one contract lifecycle. In a large-scale development, you might have a dozen cycles running at once. You have a contract lifecycle for the architect, another for the general contractor, one for the specialized structural steel fabricator, and perhaps another for the high-tech HVAC system suppliers. This overlap is where risk often hides. If the contract lifecycle for the specialized equipment is out of sync with the execution phase of the general contractor, you face delays that can cascade through the entire project. This is why parallel management is so critical. You need to ensure that the obligations in one contract don't contradict or hinder the progress of another. As we move through the rest of this lecture, we will take each of these 5 stages and examine them through 2 different lenses: the owner's perspective and the contractor's perspective. Each party has different priorities and risks to manage at every turn. Let's begin where every great project starts. Stage 1, the discovery phase. Stage 1 is the discovery phase, and it is primarily the owner's playground. Think of this as the due diligence period. Before an owner ever puts a project out to tender or signs a major agreement, they must transform a vague idea into a feasible project. If you are an owner, the last thing you want to do is engage the market with a half-baked concept. Why? Because the market will price in that uncertainty, and your costs will skyrocket before you've even broken ground. The ultimate goal of discovery is to determine viability. The owner asks, should we do this? Can we afford this? Does this align with our long-term strategy? To answer these questions, 3 key activities take place. First is project analysis, where the owner assesses feasibility against organizational goals. Second is market benchmarking. This is where you use historical data to validate your cost and schedule assumptions. You don't just guess what a hospital costs to build in 2026. You look at what similar projects cost in 2024 and 2025 and adjust for inflation and local market conditions. The third activity is creating the business case, establishing the why and what to secure internal or external funding. This document is the foundation for everything that follows. Now here is a professional strategy note. Savvy owners often use short-term, low-stakes contracts during this phase. They might hire a consultant for a feasibility study or a small firm for an interim design. This allows them to identify major risks without committing substantial capital to a full-scale contract. However, discovery isn't just for owners. Contractors and designers have their own version of discovery, and it leads to one of the most important concepts in contract management: the walk-away point. Let's see why knowing when to say no is just as important as knowing how to say yes. Have you ever seen a company win a massive contract only to go bankrupt a year later because the project was fundamentally flawed? This happens when a company forgets its walk-away point. This is a predetermined threshold based on risk and margin. It is the line in the sand where a contractor or designer says, if the risk is higher than X or the margin is lower than Y, we will not bid and we will not proceed. The logic here is purely emotional, or rather, the goal is to remove emotion. You must define this point during the discovery or business development phase. Why? Because once a team spends weeks and thousands of dollars preparing a complex bid, they become emotionally invested. They want to win. They might start making excuses for why a bad contract is actually okay. We'll make it up on change orders, they say. Or, we need the work to keep the crews busy. This is how disasters start. On the PMI-CP exam, this is a critical focus point. You will likely see a scenario where a project has undefined risks that clearly exceed a company's established risk appetite. The scenario might tempt you with options like attempt to mitigate the risk or negotiate a higher fee. But if the risk is truly unmanageable or undefined, the correct PMI-CP action is to exercise the walk-away point. Choosing not to bid is a valid and often superior strategic move. It protects the firm's financial health and reputation. Remember, no project is worth sinking the entire company. Now, assuming the owner has found the project viable and the contractors are interested, we move to stage 2, strategic selection. Once a project is greenlit, the owner enters stage 2, strategic selection. The big question here is, how do we buy? This decision usually comes down to two primary documents: the request for tender, RFT, also known as an invitation to tender, ITT, and the request for proposal, RFP. Choosing the wrong one is like trying to use a hammer to turn a screw. It's going to be messy and ineffective. Let's look at the RFT first. You use an RFT when you, as the owner, know exactly what you want. You have the detailed designs, the technical specifications are 100% complete, and you are basically looking for someone to execute your plan. The focus here is almost entirely on pricing and schedule for a very clearly defined scope. It's a competition of efficiency. Who can build this exact thing for the best price? On the other hand, we have the RFP. You use an RFP when you have a concept or a problem, but you need the market to provide the solution. Perhaps you want to build a sustainable office tower, but you aren't sure which energy-efficient technologies are best suited for the site. In this case, designs are conceptual or non-existent. The focus shifts from lowest price to innovation, methodology, and total value. You are asking experts to tell you how to do it. For the exam, remember the prerequisites. An RFT requires detailed specs. An RFP does not. If you issue an RFT with vague specs, you are inviting a world of change orders because the contractor will inevitably find gaps in your incomplete plan. Let's put this into practice with a real-world exam scenario. Imagine you are a project manager for an owner planning a complex chemical plant. This project uses brand new technology, and your internal team lacks the expertise to define the detailed technical specifications. You have a budget, and you need innovation to make this work. Now, your procurement manager, who is under pressure to move fast, suggests issuing an RFT to get the lowest fixed price quickly. What do? The exam might offer you three choices: proceed with the RFT for cost certainty, switch to an RFP, or hire a consultant to write specs and then issue an RFT. The cost certainty of an RFT is an illusion in this scenario. Because the owner doesn't have detailed designs, any fixed price given by a contractor will be based on guesses. As soon as the work starts, those guesses will turn into expensive change orders. The best action is to switch to a request for proposal, RFP. Here's the reasoning you need to remember. An RFT must be backed by detailed designs to be effective. Since the scope is undefined and the owner lacks expertise, an RFP is the only logical choice. It invites experts to propose the technical solution. Crucially, this shifts the design risk to the supplier. They are the ones telling you how it will work, so they take responsibility for the outcome. This scenario highlights a key principle. The procurement strategy must match the project's maturity. Once you've chosen your strategy, you need a fair way to pick a winner. That brings us to governance and supplier evaluation. How do we ensure that the selection process is fair and objective? It all comes down to governance. There is one golden rule you must follow. Evaluation criteria must be established internally before you ever receive a single bid. If you wait until after the bids are in to decide what matters most, you are opening the door to bias, favoritism, and even legal challenges from disgruntled losers. A professional evaluation uses a holistic scorecard. We look far beyond the lowest bid. In the built environment, the cheapest contractor is often the most expensive in the long run. We evaluate three main pillars. First, financial health. Does the company have the credit ratings, bonding capacity, and banking arrangements to finish the job? If they go bust halfway through, your project is in ruins. Second, we look at the safety record. We check their experience modification rating, or EMR, and their incident rates. Why? Because a company with a poor safety record is a massive liability. One major accident can shut down your site for weeks and lead to millions in fines and lawsuits. Third, we assess technical capacity. Have they done this specific type of work before? Do they have the management knowledge and the equipment required? The exam note here is vital. A contractor who offers a very low price but has poor safety or financial health is a high default risk. In a scenario-based question, the PMI-CP approach is to avoid these high-risk partners, even if their price is tempting. Governance keeps the project safe from short-sighted decisions. Now let's look at the actual workflow of the proposal process. Stage 3 is where the rubber meets the road, the proposal process. This stage is a structured workflow that moves from the owner's request to a signed agreement. It typically follows 4 steps. Step 1 is solicitation. The owner issues the ITT or RFP to the market. Step 2 is the Q&A window, where suppliers submit requests for information or RFIs. Step 3 is the submission and evaluation of bids, and Step 4 is selection, which includes final negotiations and signing the contract. Pay close attention to Step 2, the Q&A window. In the world of risk management, this is a critical step. If a contractor sees an ambiguity in the tender documents, they ask an RFI. The owner's answer then goes out to all bidders to ensure a level playing field. However, there is a common trap here: rushing the Q&A window. When owners or procurement teams are in a hurry, they might give vague answers or cut the Q&A period short. This is a massive risk. If a contractor doesn't get a clear answer, they are forced to make bid assumptions. They guess what the owner wants. Those assumptions inevitably lead to friction. When the contractor arrives on site and realizes the owner's expectation is different from their assumption, you get a change order. When you have dozens of these, you get a dispute. As a project leader, your job is to protect the integrity of the Q&A window. Ensure it is long enough for deep analysis and that the answers provided are technical, clear, and binding. Once the contract is signed, we move into the longest and most complex phase, execution and management. We are now in stage 4, execution and management. This is where the work gets done, but it's also where the contract language is tested every single day. Governance here is about authority. You must know who is allowed to say yes. If a project manager approves a $1 million scope change, but their delegated authority is only for $50,000, you have a process failure. Even if the change was technically necessary, the process was broken. Now let's talk about the actual words in the contract. Interpreting ambiguity is one of the most important skills you will learn. The must versus may rule is the gold standard. When a contract says the contractor must or the contractor shall, it is a mandatory obligation. It is non-negotiable. If they don't do it, they are in breach of contract. Simple as that. However, when a contract says the contractor may, it is discretionary. The party has a choice. They can do it, or they can choose not to. For the PMI-CP exam, when you are reviewing a claim or a dispute scenario, your first step should always be to check the specific verb used in the clause. One of the hardest things for engineers and technical professionals to accept is that common sense does not override the written contract. You might think it is obvious that a certain high-quality material should be used, but if the contract uses discretionary language, you cannot force that choice on the contractor without paying for it. Let's look at a scenario that illustrates exactly how this plays out in the field. Here is a classic scenario you might face. A subcontractor is installing piping for a high-pressure system using grade B materials. The owner's representative visits the site, looks at the work, and is unhappy. They point to a clause in the contract that says, the contractor may use grade A materials for high-pressure lines. The owner demands that the grade B pipes be ripped out and replaced with grade A at the contractor's expense. The conflict is clear. The owner wants the higher quality, but the contractor says they are in full compliance with the contract. What is the best action? Should you force the replacement for free? Should you deduct the cost difference? Or should you issue a change order and pay for the upgrade? The correct PMI-CP action is to issue a change order and pay for the upgrade to grade A. Why? Because the word may is discretionary. The contract did not say must use grade A. By choosing grade B, the contractor stayed within the rules of the agreement. The contractor's choice was valid. The owner's sudden demand for grade A is a change in the required scope. This reinforces the principle that you cannot punish a contractor for exercising a choice that the contract explicitly gave them. If the owner wanted grade A as a requirement, they should have used the word must during the proposal phase. Now, to prevent these kinds of misunderstandings, we need to talk about how we integrate our teams. One of the biggest systemic risks in the built environment is the handover gap. This is the problem where the team that negotiates the contract, usually legal and procurement experts, is completely different from the team that actually builds the project managers and site engineers. The negotiators might agree to a complex penalty structure or a specific reporting requirement that the site team doesn't even know exists. To solve this, we use two best practices. First is upstream integration. We bring the delivery teams into the proposal and pre-award phases. Let the engineers read the draft contract. They will spot technical impossibilities or risky obligations that a lawyer might miss. Their field perspective is invaluable before the ink is dry. The second solution is the contract review session. Immediately after the contract is awarded, you hold a session where the legal team explains the rules of the game to the delivery team. You ensure everyone understands the key obligations, the KPIs they are being measured against, and the specific risks identified during negotiation. And here is a practical field tip. Don't just leave the contract in a digital folder. Post a laminated list of the most important clauses, the ones that govern changes, delays, and safety, right on the wall of the site office. This keeps the rules top of mind for everyone. Speaking of important clauses, there are three in particular that you must master for the exam. Let's look at the clause wheel. Every contract is filled with dozens of clauses, but if you understand these three, you'll be ahead of 90% of your peers. We call this the clause wheel. First up is indemnity. This clause defines who is responsible for paying when things go wrong: liability, damages, or injuries. A key term to know here is the waiver of subrogation. This is a legal agreement that prevents insurance companies from suing one of the parties to the contract after they've paid out a claim. It's a way to keep the project moving without a web of internal lawsuits. Next is the change clause. This is the heart of project management. It describes the exact mechanism for altering the scope, time, or cost of the project. Here is a major risk: informal changes. If a project manager tells a contractor, "Go ahead and move that wall, we'll settle the paperwork later," they have just created a verbal change. Verbal changes are the number one source of disputes in construction. Without a written change order, the contractor has no guarantee of payment, and the owner has no control over the budget. Finally, we have liquidated damages, or LDs. These are pre-agreed financial penalties if the contractor delivers the project late. For example, the contract might say the contractor pays $5,000 for every day the project is past the completion date. Here is the legal catch: LDs must be a reasonable estimate of loss. They cannot be punitive. If the owner just wants to punish the contractor with a massive fine that has no relationship to actual financial loss, a court might strike the clause down. Understanding these three clauses allows you to manage the most common points of friction. But even the best managed projects eventually come to an end. That brings us to our final stage. The final stage is stage 5, closeout and termination. In a perfect world, every project ends with a successful closeout. This involves several administrative and technical tasks. You have the punch list, or snag list, where you walk the site and identify small defects that need fixing. You have the handover of operation and maintenance, O&M, manuals to the owner. Then comes the final accounting, resolving open claims and releasing the retainage, which is the money the owner held back to ensure the contractor finished the work. But what happens if a project ends early? This is called termination. There are two types you must know. The first is termination for cause. This happens when one party, usually the contractor, fails to perform or breaches the contract. Maybe they are months behind schedule with no plan to catch up, or they've stopped paying their subcontractors. In this case, the owner ends the contract because the contractor failed. The second type is more common in shifting economies: termination for convenience. This is where the owner decides to stop the project even though the contractor has done nothing wrong. Maybe the market collapsed, or the owner lost their funding. Most standard contracts give the owner the right to do this. However, the payment rules for convenience are specific. The owner typically pays for all work done up to that date, plus exit costs or demobilization costs, like moving equipment off-site. Here is the critical exam insight. The owner does not have to pay the contractor for the profit they would have made on the work they didn't get to do. The contractor is made whole for their effort, but they don't get a windfall. Let's look at one last scenario to see this in action. Imagine a project that is 60% complete. The contractor has performed perfectly. They are on time, on budget, and the quality is excellent. Suddenly, the owner's market collapses, and the facility is no longer viable. The owner wants to stop all work immediately. The contractor, understandably upset about losing the rest of the job, demands full payment for the remaining 40% of the contract value, claiming they had allocated resources for the whole year. What is the best course of action for the owner? Does the owner have to keep going because the contractor isn't at fault? Do they have to pay the full 100% of the contract as a penalty? The answer is no. The owner should exercise the termination for convenience clause. Under this clause, the owner has the right to stop work at any time. They will pay the contractor for the 60% of the work already completed, plus any documented exit costs, such as the cost of breaking leases on equipment or sending crews home. The reasoning here is that standard modern contracts are designed to provide flexibility for the owner while ensuring the contractor isn't left with out-of-pocket losses. The contractor's demand for the full contract value, including the profit for work they never performed, will almost never be upheld unless the contract has very unusual, non-standard language. Understanding this protects the owner's capital and sets realistic expectations for the contractor. We've covered a lot today. As we close Lecture 14, remember these 4 pillars, vital for both your exam and your career. 1. Life cycle awareness. Each phase, discovery, pre-award, proposal, execution, closeout, is a unique challenge. Miss discovery, you risk execution. Skip closeout, you might not get paid. 2. Active governance. A contract isn't shelf decor. It's a tool. Use it to assign authority, set expectations, and manage risk. Govern before things go wrong. 3. Clarity is king. May versus must can make or break a project. Ambiguity fuels disputes. As a PMI-CP, you eliminate gray areas with clear language and sharp RFIs. 4. Alignment. Tear down silos. Contracts and job sites must talk. When legal and field teams are aligned, projects succeed. Have you ever wondered why some multi-million-dollar construction projects finish ahead of schedule while others dissolve into years of legal battles over a single pipe fitting? The answer rarely lies in the quality of the concrete. It lies in the DNA of the project, the delivery method. In the built environment, choosing how we organize the team is the single most significant predictor of project success. First, let's look at the traditional heavyweight, design bid build, or DBB. In this model, the owner bears a massive 85% of the risk. Because the design and construction phases are strictly separated, the environment often becomes adversarial. If a drawing is wrong, the contractor blames the designer, and the owner ends up paying the bill. It is highly fragmented, meaning the people building the project have zero input during the design phase. Next, we move to a more streamlined approach, design build. Here, the owner's risk drops to 50%. This is because of the single point of responsibility. The owner signs one contract with a single entity that handles both design and construction. This allows for fast tracking, where construction can start before the total design is finished, significantly increasing delivery speed. Finally, we have the modern gold standard, Integrated Project Delivery, or IPD. This is a shared risk and shared reward model. The owner's risk is at its lowest, just 20%, because the designer, the contractor, and the owner legally agree to act as one team. If the project saves money, everyone wins. If it goes over, everyone shares the loss. This collaboration eliminates the blame game, typical of traditional methods. Understanding these percentages is crucial because they dictate who holds the checkbook when things go wrong. Now let's look at how the primary players must align to make these methods work. Imagine trying to lead a three-legged race where everyone is running at a different speed and looking in a different direction. That is exactly what happens in a construction project without strategic alignment. Every built environment project requires a specific mixture of planning, design, and construction services executed by three key parties: the owner, often called the client or employer, the designer, typically the architect or engineer, and the contractor, the builder. At the heart of this triad is the contract and delivery method. This is the glue that holds the three parties together. A key insight for any project manager is that this decision must be made before design begins. You wouldn't choose a flight path after the plane has already taken off, and similarly, you cannot effectively design a building without knowing how it will be bought and built. This decision has a massive ripple effect on three major areas: First, it dictates team communication channels. Will the designer and contractor speak every day, or are they forbidden from talking until the bid is won? Second, it defines payment distribution and cash flow, basically who gets paid, when, and for what. Finally, it establishes roles, responsibilities, and risk apportionment. If there is a gap in the contract where a responsibility isn't clearly assigned, that gap eventually turns into a dispute. To avoid these gaps, we need a structured way to evaluate the project. Let's examine the 5 factors that drive this selection process. Is the cheapest delivery method always the best? Not necessarily. To choose the right path, an owner must evaluate the project against 5 specific success factors. Think of these as the stress test for your project strategy. First is budget. This isn't just the total number, but the certainty of that number. Does the owner need a guaranteed price before they even start, or do they have the flexibility to pay as they go? Second is design. This covers both functionality, does the building work, and aesthetics. Does it look the way it's supposed to? Some methods, like DBB, give the owner total control over design, while others, like design build, might sacrifice some aesthetic control for the sake of speed. The third factor is risk. We define this as exposure to loss or harm. Every project has risks: weather, labor strikes, material shortages. The question is, who is best equipped to handle them? Fourth is the schedule. If you are building a stadium for the Olympics, the date is non-negotiable. In that case, you need a method that supports fast tracking or accelerated delivery. Finally, we have owner expertise. An owner who has built 50 hospitals has different needs than a small business owner building their first warehouse. The more experienced the owner, the more risk they may be willing to manage personally. If the owner is inexperienced, they should choose a method that shifts management to a professional. To make this evaluation scientific rather than emotional, the industry uses specific tools. How do we turn subjective opinions about risk and quality into an objective business decision? We use the PDCS procedure, which stands for Project Delivery Selection System. This tool was developed by the Construction Industry Institute, or CII, to take the guesswork out of the process. The procedure follows a logical 3-step flow. First, we identify selection factors. We align our project objectives with the owner's ultimate goals. For example, is speed to market more important than initial cost? Second, we assign preference weights. Not every factor is equal. In a high-tech data center project, technical complexity might have a weight of 40%, while aesthetics might only be 5%. Third, we input these into a specialized Microsoft Excel workbook to obtain aggregate scores. For those of you interested in the technical details, the tool provides a quantitative assessment of 12 different decision-making alternatives. It uses sum product functions, which multiply your user-defined weights by the relative effectiveness values of each delivery method. The output is a clear, data-driven ranking that tells you which method is most likely to succeed for your specific constraints. Once the tool helps us choose a direction, we need to understand the specific flavors of delivery methods available. We'll start with the traditional and management-based models. Let's break down the 3 most common ways to organize project contracts. First, we have the traditional method, Design Bid Build, or DBB. Think of this as a relay race. The designer completes 100% of the plans, hands the baton to the owner, who then puts it out for bid. The lowest price contractor wins and starts building. The owner holds 2 separate contracts, one with the designer and one with the contractor. It's simple and well understood, but it's slow because no construction can happen until the design is completely finished. Next, we have the construction manager at risk, or CMR. In this model, the owner hires a construction manager early on, during the design phase. The CM acts as a consultant, offering value engineering to find ways to save money while the drawings are still being made. Once design is far enough along, the CM provides a guaranteed maximum price, or GMP. From that point on, the CM is at risk. If the project costs more than the guarantee, the CM pays the difference. The third version is Professional Construction Management, or PCM. Here, the CM is purely an agent or advisor. They represent the owner's interests, but the owner is the one who actually signs the contracts with all the individual trade contractors, like electricians and plumbers. This gives the owner a lot of control, but requires them to be very involved in the day-to-day paperwork. While these are the big three, other methods like multi-prime or job order contracting also exist for specialized needs. Next, we'll move from these management-based models to more integrated and alternative structures. As projects become more complex, we see a shift away from siloed roles toward high collaboration. The most famous example is design-build. Unlike the traditional method where you have two contracts, here you have just one. The design builder is a single entity responsible for everything. For the owner, this is fantastic because there is no one else to blame. It's a single point of responsibility. If the roof leaks, the design builder fixes it. They can't claim it was a design error because they were the designer. Taking collaboration to the absolute limit is integrated project delivery, or IPD. This is often used for highly complex buildings like hospitals. In IPD, the owner, designer, and builder are legally bound by a single contract where they share both risks and rewards. If the team finds a way to save $1 million, they all split that savings. This incentivizes the contractor to help the designer and vice versa. Finally, we have alternative structures often used for massive infrastructure like toll roads or bridges. In a public-private partnership, or P3, the private sector helps finance and deliver public projects. A specific version of this is Build, Operate, Transfer, or BOT. In a BOT project, the contractor doesn't just build the facility. They actually finance it and operate it, like collecting tolls, for a set period, maybe 20 or 30 years, to recoup their investment before finally transferring ownership back to the government. Regardless of the method, the backbone of the project is the written contract. Let's look at the standard forms used in the industry. What exactly is a contract in the built environment? It isn't just a piece of paper. It's a legal manual that defines roles, responsibilities, and exactly what work must be done. Because construction is so risky, the industry has developed standard forms of contract, or SFOCs. Instead of writing a new contract from scratch for every project, which would be incredibly expensive and legally risky, we use predetermined frameworks created by authoritative bodies. You may have heard of the JCT in the UK, the NEC for engineering, or FIDIC for international projects. These boilerplate agreements are used because everyone knows what they mean. They increase procurement efficiency and ensure that the legal plumbing of the project is solid. However, there is a major warning here for project managers. Beware of bespoke contracts. Often, an owner's lawyer will try to heavily amend a standard form to shift even more risk onto the contractor. While this might look good on paper, it often creates legal uncertainty. If you change the standard language, a judge might interpret it in a way you didn't intend, or the contractor might raise their price significantly to cover the unfair risk. A better way to manage risk is through the payment structure itself. Let's look at how the money flows. If the delivery method is the skeleton of a project, the payment structure is the circulatory system. It dictates how compensation flows, and more importantly, who loses money if the project gets expensive. There are 7 primary ways we structure payments. The most common is the lump sum. This is a fixed price for the entire scope. If the contractor says they will build it for $10 million, they get $10 million, even if their own costs go up to $11 million. At the opposite end is cost plus a fee. Here, the owner pays for every nail and every hour of labor, plus a fixed or percentage fee for the contractor. This is great for the contractor, but risky for the owner. To balance this, we often use a GMP, or guaranteed maximum price, which puts a cap on a cost-plus contract. For heavy civil projects like moving earth or paving roads, we use unit price or ad measurement. This is where you pay based on quantities. For example, $50 per cubic yard of dirt moved. If the contractor moves more dirt, they get more money. We also have target cost contracts, which include incentives. If the contractor finishes under a target budget, they get a bonus. Finally, there is time and materials, or T&M, usually reserved for small repairs or emergency work where the scope is unknown. Understanding these is vital because they create a risk spectrum. Let's visualize that spectrum now. When it comes to project finance, risk is like a seesaw. When it goes down for one person, it goes up for the other. The payment structure you choose determines exactly where that seesaw sits. On one side of the spectrum, we have high contractor risk. This is the lump sum model. In this scenario, the owner is highly protected because the price is locked in. If the price of steel doubles overnight, the contractor absorbs that cost overrun. Because of this, contractors will often include a contingency or a buffer in their price to protect themselves. On the other side, we have high owner risk, typified by cost plus or time and materials. In these models, the contractor has minimal risk because they are reimbursed for everything they spend. The danger for the owner is that there is no incentive for the contractor to be efficient. If the workers take twice as long to do a task, the owner pays twice as much. The sweet spot is usually in the middle, with GMP or target cost models. These create a shared risk environment where both parties have skin in the game. Understanding this spectrum allows an owner to choose a payment method that aligns with their tolerance for budget surprises. But before we sign the contract, we have to choose who gets it. Let's look at the methods of contract award. How do you actually pick your partner for a multi-year, multi-million-dollar project? There are 4 main ways to award a contract. The most traditional is the competitive bid. In this hard bid scenario, the owner provides the plans and several contractors submit their prices. The owner simply selects the lowest price. This is common in government work, but it can lead to problems if the contractor bid too low just to win the job. To fix the flaws of low bid selection, many owners use best value selection. This uses a weighted criteria approach. We look at quality, past experience, the proposed project plan, and cost. A contractor might have a slightly higher price, but a much better safety record and faster schedule, giving them the highest aggregate rating. A middle ground approach is the pre-qualified bid. This is a 2-step process. First, the owner creates a short list of contractors who have the right experience and financial strength. Then, only those on the list are allowed to submit a price, and the lowest price among them wins. Finally, there is negotiated selection. This is where the owner just picks their favorite contractor and negotiates the price directly. This is common in the private sector, but is rarely allowed in public projects due to anti-corruption laws. Once the award is made, we must define the specific risks buried in the contract, fine print. What exactly are we afraid of when we sign a contract? We categorize contract risk into 2 buckets: performance risk, can they actually build it? And cost risk, will it stay on budget? To manage these, lawyers use disclaimer clauses to shift risk away from the owner. There are 5 you must recognize. First is uncertainty of work conditions. This clause shifts the risk of unknown site conditions, like finding a buried oil tank or hard rock onto the contractor. Second is delaying events. This limits the contractor's ability to claim extra time or money for things like bad weather. Third is indemnification. This is a hold harmless agreement. If a passerby gets hurt by a falling brick, this clause ensures the contractor's insurance pays for the lawsuit, not the owner's. The fourth, and perhaps most famous, is liquidated damages. These are pre-agreed financial penalties for late delivery. If the contract says the project must be done by June 1st, the contractor might have to pay $5,000 for every single day they are late. It's important to note that these are for damages, not punishment. Finally, there is sufficiency of contract documents. This forces the contractor to assume responsibility for the completeness of the drawings. If a door is missing from a drawing but reasonably inferred, the contractor has to provide it. These clauses are powerful, but if mismanaged, they lead to strategic failure. Sometimes, in our effort to protect ourselves with legal clauses, we actually end up sabotaging the project. These are strategic contract risks. The biggest culprit is misaligned incentives. If the contract only rewards the contractor for being cheap, they will cut corners on quality. If it only rewards speed, they might ignore safety. The goal is a contract where, when the project wins, everyone wins. Another major risk is inappropriate risk allocation. There is a golden rule in construction. Risk should be assigned to the party best able to manage it. If an owner tries to shift the risk of national inflation onto a small local contractor, the contractor can't do anything to control that risk. They will simply raise their price to an astronomical level to cover the uncertainty, which increases the total project cost for the owner. Finally, we have the issue of increased complexity. The world is moving toward relational contracts, long-term partnerships where things change constantly. Traditional stone-set contracts that try to predict every single detail for the next 5 years often fail because they aren't flexible enough. When complexity goes up, we need a legal framework that allows for adjustment, not just litigation. Beyond these big-picture strategies, there are administrative traps we must avoid. While the big risks get all the attention, it's often the paperwork that kills a project. Let's talk about administrative and financial risks. First, insurance. Many project managers perform a passive review of insurance certificates. They just see a piece of paper and file it away. This is dangerous. If the certificate has incorrect info, omitted exclusions, or is written on a non-binding form, the owner might find themselves with zero coverage when a disaster strikes. Next are general conditions risks. The general conditions define how the job site is run. Things like who pays for the trailers, the temporary power, and the cleanup. If these are vaguely defined, they become a breeding ground for disputes and extra hidden claims at the end of the project. Finally, we have pricing risks. One of the most dangerous things for an owner is a contractor who underbids. If a contractor bids so low that they can't make a profit, they might go insolvent halfway through the project, leaving the owner with a half-finished building and a legal nightmare. We also have change order management. If the process for changing the scope isn't crystal clear, every tiny adjustment becomes a battle over price. To help you prepare for your professional exams, let's boil all of this down into the highest yield concepts. If you are studying for a professional certification, this is the slide you need to memorize. Let's look at the high yield concepts that appear most often. First, remember that DBB, design bid build, is sequential. Design must be 100% done before bidding. It offers great cost control because you know the price before you start building, but it is the slowest method. Contrast that with design build, or DB. The key phrase here is single point of responsibility. This is the method that allows for fast tracking or overlapping the design and construction phases to save time. When it comes to payment, remember the extremes. Lump sum is the maximum risk to the contractor, while cost plus is the maximum risk to the owner. Don't fall for the exam traps. For example, remember that negotiated selection is almost never allowed in public or government projects. They require open competition. Also, remember the legal definition of liquidated damages. They are specifically for delay penalties and must be a reasonable estimate of the actual money the owner loses. They are not allowed to be a general punishment intended to hurt the contractor. Finally, always lean on standard forms of contract, like FIDIC or NEC, to minimize legal uncertainty. Let's wrap up with a summary of how these pieces fit together. Success in the built environment isn't about luck. It's about the deliberate alignment of three specific elements. Think of these as a cycle that must remain in balance. First is the delivery method. This is how we organize the team. Are we a relay race or a single team? Second is the contract structure. This is our legal framework. Are we using a standard form that everyone trusts, or are we taking a risk with a bespoke agreement? Third are the payment terms. This is risk allocation. Who holds the financial burden if the world changes during the project? Ideally, your chosen framework supports the owner's primary objectives, whether that is a strict budget, a fast schedule, or a specific risk tolerance. When these three elements are aligned, all parties are incentivized correctly. The contractor wants the project to succeed, the designer wants the project to succeed, and the owner is protected. Appropriate risk allocation is the best way to prevent the costly disputes and litigation that plague our industry. By choosing the right DNA for your project at the very beginning, you set yourself up for a finish that is on time and on budget. We've covered a significant amount of ground today, from the high-level theory of integrated project delivery to the fine print of liquidated damages and insurance certificates. At this stage, I want to open the floor to your questions. Perhaps you've encountered a specific bespoke contract that caused issues, or maybe you're curious about how to apply the PDCS tool to a project you are currently planning. Whatever the case, let's dive into the details. What questions do you have about delivery methods and risk allocation? Think about the last major construction project you were involved in. Was it delivered exactly on time and on budget, or did an unforeseen event throw a wrench in the gears? In the world of the built environment, risk isn't just a possibility, it's a certainty. The real question is whether you are identifying these risks early enough to do something about them, or simply reacting when they turn into crises. Welcome to this session on risk identification and prioritization in construction projects. Our primary goal today is to move beyond the idea of risk management as a mere safety exercise and look at it as a comprehensive strategy for project success. We will specifically focus on front-end planning, the critical period before a shovel even hits the dirt, and how lifecycle mitigation can protect a project from inception through to the final handover. We will explore how to take a structured approach to identifying potential pitfalls, and more importantly, how to prioritize them so that your team's energy is focused on the issues that truly matter. By the end of this session, you'll have a clearer understanding of how to weave risk management into the very fabric of your project's lifecycle. To get started, let's establish the framework for what we hope to achieve today. Have you ever wondered why some project managers seem so much calmer than others when a supply chain issue arises? It usually isn't luck. It's because they've already classified, prioritized, and planned for that exact scenario. Today, we are going to learn how to build that level of professional resilience. Our roadmap for this session is built around 4 key pillars. First, we will learn how to classify risks. Not all risks are created equal, and by categorizing them into groups like technical, commercial, or environmental, we can better track their intended and unintended impacts. Second, we will look at the prioritization process, specifically during front-end planning. This is where we decide which risks are deal breakers and which can be managed with standard procedures. Next, we emphasize the review phase. A risk register is not a static document that sits on a shelf. It requires frequent reviews of the prioritization matrix to stay relevant as the project evolves. Finally, we want to shift your mindset to see risk identification not just as a defensive move, but as a tool for improvement. By understanding where the weak points are, we find the best opportunities to improve overall project performance. This matters because contract management is inherently complex, and owners must remain vigilant. Efficient risk management is the single most important key to ensuring the successful delivery of a built environment project. Before we dive into the how, Let's take a moment to define exactly what we mean when we talk about risk management. Is risk management about eliminating risk entirely? Actually, that is a common misconception. In reality, it's about control. Peter Bernstein, a famous economist, once noted that the essence of risk management lies in maximizing the areas where we have some control over the outcome while minimizing the areas where we have absolutely no control. Think of it like a scale. On one side, you have external factors like a sudden global pandemic or a once-in-a-century flood. You can't control those events, so your goal is to minimize your exposure to them. On the other side, you have internal factors like your procurement strategy, your choice of subcontractors, and your design accuracy. These are areas where you can exert control. Effective risk management tips the scale in your favor. Formally, we define this as a structured process. It isn't just a gut feeling. It involves 5 distinct steps: identifying what could go wrong, classifying the type of risk, analyzing its potential impact, prioritizing it against other issues, and finally, mitigating it through specific actions. This is a continuous effort that spans the entire project lifecycle, from the very first initiation meeting to the final handover. Now that we have a solid definition, let's look at the core principles that drive this process and the benefits they bring to your project. What does a successful project look like to you? Usually, it boils down to 5 things. It's safe, it's high quality, it's productive, it stayed on schedule, and it didn't blow the budget. These aren't just goals. They are the direct outcomes of applying solid risk management principles. Let's break down the implementation principles visible here. First, we identify. This means walking the site, reviewing the plans, and locating every potential risk associated with the project. Next, we analyze. Here, we determine if a risk is significant, meaning it could stop the project in its tracks, or minor, meaning it's a nuisance we can handle. Once we've validated a risk, our goal is to reduce it. We want to offset these risks as far as is practically possible. Finally, we mitigate. This is where the rubber meets the road. We arrange for the actual implementation of strategies, such as buying insurance, changing a design element, or adding a contingency fund. The why behind this is clear. When you manage risk effectively, you see an immediate increase in safety and quality. Furthermore, you reduce the friction in a project, which naturally leads to reduced time and cost. It's about moving from a reactive firefighting mode to a proactive problem-solving mode. To do this effectively, however, we must be able to categorize what we are looking at, which brings us to the necessity of classification. Have you ever had a team meeting where 2 people disagreed on how dangerous a specific risk was? That happens because risks are inherently complex and subjective. What feels like a major risk to a site supervisor might feel minor to a financial controller. This is why we need a standardized way to classify and measure them. Classification is essential because it allows us to track the root causes of risks. By correctly labeling a risk, we can better understand its ripple effect, the intended and unintended impacts it might have on other parts of the project. The challenge for us as professionals is to remain completely objective. We can't rely on gut feelings. We need data. The tool we use to achieve this objectivity is the risk matrix shown here. We plot every risk based on 2 variables: the likelihood of occurrence, from very low to very high, and the relative impact, from negligible to extreme. A risk that is very high likelihood and extreme impact is a project killer that needs immediate attention. Conversely, a very low likelihood risk with a negligible impact might just be something we monitor. By using this matrix, we can turn subjective fears into an objective, color-coded plan of action. Next, let's look at how these risks specifically affect the different players in a project, starting with the clients. If you are an owner or a client, your perspective on risk is often tied to the long game. From a strategic standpoint, many owners try to minimize their exposure by passing risks down to contractors. The logic is that this lowers administrative costs and forces higher competition, but be careful. Just because you've passed a risk to someone else doesn't mean you are immune to the consequences if they fail. For a client, the most obvious risk is monetary loss. This isn't just about the construction cost. It's about the benefits realization. If a hotel is finished 6 months late, that is 6 months of lost room revenue that can never be recovered. Another major factor is poor advice. If an owner is given an inappropriate procurement strategy or poor management tools, the project is doomed before it starts. We also have to consider project delays caused by supply chain inefficiencies or disputes and unforeseen issues that lead to variations and extra costs. Finally, there is the long-term risk of cost containment. If a building is constructed with defects or a poor design, the owner will be stuck with higher maintenance and running costs for decades. In short, the owner's risk is often about the total cost of ownership and the viability of the business case. Now let's pivot and see how these pressures change when we look at the project through the eyes of the designer. Designers often find themselves caught in the middle. They are expected to deliver a perfect vision, often with imperfect information. One of the biggest risks here is the resource and experience gap. This happens when a project's complexity exceeds the designer's past experience, or when the owner lacks the internal resources to actually make decisions on the design. Procurement and definition issues are another major hurdle. If responsibilities aren't clearly defined at the outset, or if the procurement strategy is so restrictive that it blocks the designer from giving meaningful input, the quality of the final product will suffer. We also see significant documentation risks. If the initial briefing documents are poor, or if the product information used for specifications is inaccurate, the design is essentially a house of cards. Finally, we have the process issues that eat away at a designer's profitability and morale. Excessive change requests from a fickle client, delayed approvals that stall the workflow, and the ever-present issue of delayed payments. Poor record keeping can also be a silent killer if a dispute arises later. For a designer, risk management is often about managing the client as much as it is about managing the drawings. This brings us to the third leg of the stool, the contractor. For a contractor, the risk begins long before the first brick is laid. It starts during the tender process. Imagine trying to price a job where the briefing documents are poor, or the various sets of drawings don't coordinate with each other. That isn't just an inconvenience, it's a financial trap. Using non-standard contract documentation adds another layer of risk, as it can contain hidden clauses that shift unfair levels of liability onto the contractor. Then, there are the client-related risks. Every experienced contractor has a story about an owner who will not commit. When a client is indecisive or inexperienced, it creates a bottleneck that slows down the entire site. Even worse is a client who fails to acknowledge or reward quality. If the owner only cares about the lowest price and doesn't value the extra mile the contractor goes to ensure quality, the relationship quickly becomes adversarial. Lastly, we have the cash flow killers, delayed payments and approvals. Construction is a high-volume, low-margin business. If a contractor doesn't get paid on time, they can't pay their subs or suppliers, and the project can grind to a halt. While these are administrative and relationship risks, the contractor also faces a mountain of physical and execution risks, which we will examine next. Now we get into the boots-on-the-ground risks that keep contractors awake at night. First and foremost are site conditions. You can do all the soil testing in the world, but until you start digging, you never truly know what's down there. Unexpected contamination or poor ground conditions can add millions to a project's cost in an instant. Then we have execution risks. Sometimes a design looks great on a computer screen, but is nearly impossible to build efficiently. This is what we call poor constructability. This is often compounded by coordination problems, especially when dealing with highly specialized subcontractors who must work in a very tight sequence. And of course, there is the one thing no one can control: weather. A week of heavy rain can destroy a carefully planned schedule. We also have to manage resource and safety risks. A supply chain failure, like a factory closing or a shipping delay, can stop work for weeks. Faulty materials or components that arrive on site defective are another major headache. But the most serious risk is always safety. An accident or injury on site is a tragedy first, but it's also a massive legal and financial risk. Finally, a poorly trained workforce or industrial disputes can lead to low productivity. As you can see, the list is long, which is why we need high-level categories to keep us organized. With so many different risks floating around, how do we make sure we aren't missing the forest for the trees? We use high-level classification categories. This ensures that the project team maintains a balanced perspective and doesn't just focus on one area, like safety, while completely ignoring another, like financial viability. Our first bucket is technical and construction risks. These are the internal risks. They involve how we manage the project, whether we have enough resources, and whether our internal company policies are strong enough to support the work. If we miscalculate the time needed for a task, it falls into this category. The second bucket is commercial risks. These are often external or market-based. They include how competitive we need to be to win the work, the specific terms of our contracts, our financial stability, and how we interact with stakeholders. If a project is at risk because a key stakeholder is protesting the development, that is a commercial risk. The third bucket is environmental and social risks. This covers everything from occupational health and safety on site to the potential for natural disasters like earthquakes or floods. By dividing our risk register into these three pillars, we ensure a 360-degree view of the project's health. Let's take a closer look at the specific details within the technical and commercial categories. Let's drill down into some specific examples of technical and commercial risks, as these are where most day-to-day project issues live. Under project risks, the biggest threat is often human error at the management level. This could be a lack of proper project management training, inadequate company policies that don't catch errors, or, most commonly, a simple miscalculation of the resources or time needed to finish a job. Moving to the commercial side, we have competitiveness risks. We see this often in a down market. A company feels pressured to match a competitor's incredibly low price or aggressive delivery terms just to win the contract. The risk, of course, is that they've now won a project that is guaranteed to lose money or strain their resources to the breaking point. Then we have the teeth of the commercial side: contractual risks. The most common example here is liquidated damages, financial penalties that the contractor must pay for every day or week the project is late. If you are a month behind on a major stadium or hospital, those penalties can be enough to bankrupt a firm. Understanding these specific pressures allows us to create better mitigation strategies. Next, we will look at the details of financial and environmental risks. Our final set of detailed categories covers the macro environment. Financial risks are often outside the project team's direct control, but have a massive impact. For example, a sudden rise in interest rates can make an owner's financing much more expensive, or a spike in oil prices can drive up the cost of every delivery to the site. We also have to watch out for overtrading, taking on more work than your cash flow can support. Stakeholder risks are all about communication. If there is a breakdown in communication between the owner, the contractor, and the community, or if someone misunderstands what a deliverable actually is, disputes are inevitable. Insufficiency of funds is another major stakeholder risk. If the client runs out of money halfway through, everyone loses. On the environmental and social side, we have occupational risks. These aren't just accidents. They are often caused by poor safety behaviors, outdated methodologies, or using technologies that the staff hasn't been trained on. Finally, We have natural disaster risks, things like floods, earthquakes, or even a local landslide that makes site access impossible. While you can't stop a flood, you can have a contingency plan for what to do if the site is underwater for 2 weeks. All of this planning is most effective when it happens early, which leads us to the concept of front-end planning. When is the best time to think about risk? If your answer is when the project starts, you might already be too late. The most critical phase for risk management is actually front-end planning, which happens right after initiation but before the heavy execution begins. This is the sweet spot where you have the most influence over the project's outcome for the lowest cost. To help with this, we use a tool called the IPRE, or Integrated Project Risk Assessment. Developed by the Construction Industry Institute, this is a standardized framework that allows teams to identify and gauge risks before they become problems. One of the best things about the IPRA is its flexibility. It isn't a one-size-fits-all checklist. It can be scaled up for a multi-billion-dollar infrastructure project or scaled down for a simple commercial renovation. The key takeaway here is that risk management is proactive and continuous. It doesn't stop once the planning phase is over. You carry these assessments through execution and all the way to handover. Think of the IPRE as your project's immune system. It's always running in the background, identifying threats and helping the project stay healthy. Let's look at the specific benefits of using a standardized approach like this. Why bother with a standardized tool like the IPRE instead of just making our own list? The answer is consistency. When everyone on a project uses the same terminology, there is no confusion. When I say a risk is high, everyone knows exactly what that means because we are using standardized definitions. A standardized checklist ensures that we are systematic. It prevents that sinking feeling you get halfway through a project when you realize everyone forgot to check the local utility easements. This process also helps us predict disruptions and disputes before they happen. If the IPRA highlights a poorly defined area in the design, that is a red flag telling us to fix it now, rather than fighting about it later during construction. Furthermore, it allows for alignment and communication. It gets the owner, the designer, and the contractor on the same page. It also enables benchmarking. You can look at how you managed risks on a similar project 3 years ago and apply those lessons to the current one. Finally, it serves as a great training and education tool for junior staff. It's about building a repeatable, reliable system for success. Now, let's look at how this all fits into a continuous cycle. Risk management isn't a one-and-done task. It's a circular, never-ending process. If you treat it like a checkbox on a form, you will fail. Instead, you need to view it as a process cycle aimed at continuous improvement. It starts with identification, finding the risk. Then comes assessment and analysis, understanding how bad it is and how likely it is to happen. The next step is critical, mitigation. What are we going to do about it? Once we have a plan, we have allocation. This is where we decide who is best placed to manage that risk. Should it stay with the owner or should it be transferred to the contractor? But the cycle doesn't end there. We must monitor the risk to see if our mitigation strategy is actually working. Finally, we do an evaluation of results. Did the risk happen? Did our plan save us? This evaluation feeds back into the next round of identification. By constantly turning this wheel, your team gets smarter, and your projects get safer with every rotation. To make this work, however, you need the right tools and the right team mindset. If you think risk management is just the project manager's job, you're setting yourself up for a surprise. Risk management is a team sport. While the PM might be the one maintaining the document, the entire team, from the site engineer to the procurement officer, must own the identification and mitigation of risks. The playing field for this sport is the risk register. This is a rigorous, repeatable tool where we record every risk, its description, its probability, and our mitigation plan. It's a living document. One of the best ways to keep it alive is through regular workshops. These are formal sessions where the team gets together specifically to hunt for new risks and check the health of our current plans. In these workshops, we also focus on tracking and closing. There is nothing more satisfying than closing out a risk, marking it as no longer a threat because the dangerous phase of work is finished or the mitigation was successful. This allows the team to stop worrying about old issues and focus all their mental energy on the remaining live risks. When done right, the risk register becomes the pulse of the project. A common complaint from senior management is that risk management costs too much time and money. Our job is to show them that risk management isn't a cost. It's a value add. It is the insurance policy that protects your critical path. By investing in this process, you get 3 massive rewards: predictable estimates, no more 20% budget overruns; disaster prevention, heading off issues before they become catastrophic; and reliable project delivery. We can also use failures as opportunities. By conducting breach and near-miss analysis, we can figure out why a safety rule was broken or why a communication breakdown happened and take remedial action immediately. Ultimately, we are trying to build a proactive culture. This means moving away from a culture of blame and toward a culture of lessons learned. We want every team member to feel empowered to flag a risk without fear of being told they are being negative. When the whole team is looking for ways to protect the project, success becomes much more likely. To see how this works in the real world, let's look at a scenario involving building cladding. Let's look at a classic example of how a risk register saves a project. Imagine a designer chooses a very specific high-end cladding for a building. Everything looks great until the procurement team realizes, months later, that there is a global shortage of this material. Suddenly, the price has doubled, and the lead time is 6 months longer than expected. In a project without risk management, this would be a disaster found out far too late. But in our structured system, as soon as procurement flags the issue, it is added to the risk register. A specialist team immediately conducts an analysis. They look at the budget implications and how a 6-month delay would affect the overall schedule. Then, they present the owner with clear contingency options. Option A: switch to a similar, more available alternative material. Option B: stick with the original design, but release funds immediately for a bulk buy and arrange for off-site storage. Because this was caught early through timely coordination, what could have been a project-stopping crisis is converted into a simple, managed business decision. This is the power of the process in action. Beyond just avoiding disasters, a strong risk management strategy yields several secondary benefits that improve the overall health of your organization. First is enhanced collaboration. When you have regular risk workshops, people from different departments actually talk to each other. The designers talk to the site teams, and the accountants talk to the engineers. This breaks down silos and creates a more cohesive team. Second, it changes the vibe of the project from reactive firefighting to proactive management. There is much less stress on a project when the surprises have already been planned for. This also leads to increased confidence. When a project manager goes to the board of directors, they can explicitly articulate the risks and show exactly how they are being managed. This makes decision makers much more likely to approve budgets or new phases of work. Finally, all of this leads to more effective cost and schedule management. You aren't just hoping to hit your targets. You are actively steering the project toward them. It's about being in the driver's seat rather than just being a passenger on a runaway train. To wrap things up, let's review the key concepts you'll need for the upcoming exam. As we conclude this session, let's highlight the must-know concepts for your assessment and, more importantly, for your professional career. First, remember the Bernstein definition. The goal is to maximize the areas where you have control. If you remember that, you'll always understand the why behind what we do. Second, remember the timeline. Risk management is a continuous process that runs from the very first day of initiation all the way to handover. Within that timeline, the iParade tool is most critical during the front-end planning phase. Don't be fooled by the transfer of risk. While owners often try to pass risk to others, the consequences, like poor quality or legal disputes, almost always find their way back to the owner eventually. Know your three pillars: technical, commercial, and environmental. And finally, understand the social side of the tool. The risk register is the heart of the process. It is managed by the project manager, but it is owned by the entire team. To keep it effective, you must perform frequent reviews of the prioritization matrix. Thank you for your time today. By applying these strategies, you are not just managing a project, you are ensuring its success in an uncertain world. Have you ever wondered why some massive construction projects finish ahead of schedule while others collapse under the weight of unforeseen costs? The difference rarely comes down to luck. It comes down to a rigorous, structured approach to uncertainty. Welcome to our deep dive into the risk management framework and process, specifically tailored for the complexities of the built environment. In this sector, where physical structures meet legal, financial, and environmental hurdles, winging it is never an option. First, we will establish a foundation by looking at the high-level strategies used to navigate uncertainty. Next, we will examine the specific tools, the nuts and bolts of risk, that allow professionals to quantify what is currently unknown. Finally, we will explore delivery models, which act as the skeletal structure for how risk is shared and moved between owners and contractors. This matters because a failure to manage risk isn't just a budget issue, it's a safety and professional integrity issue. By the end of this session, you will be able to transform vague project anxieties into a disciplined delivery strategy. Let's start by defining what risk actually looks like versus how we feel about it. Think back to a project where a team member was convinced a certain site was a nightmare, only to find the soil was perfect. Or conversely, a site that looked easy, but hit a logistical disaster. Why does this happen? It's because of the gap between perceived risk and actual risk. Perceived risk is the cloud of uncertainty we feel at the start of a project, often shaped by fear or incomplete data. Actual risk is the concrete reality of what will happen. The bridge between that cloud of perception and the hard cube of reality is built on two pillars: information availability and experience and expertise. First, the more data we have, the availability, the smaller the gap becomes. Next, the expertise of the team allows us to interpret that data correctly. This is why risk management is a collective team responsibility. No single person has all the answers. This matters because our assumptions are influenced by local conditions and the stability of the information we receive. If our assumptions are shaky, our perception will be miles away from reality. Now that we understand how we perceive risk, let's look at how risk is organized within an organization. Imagine you are building a new hospital wing. Is your biggest threat a global cement shortage or a specific welder missing a deadline? The answer is both, but they exist at different levels of the risk management hierarchy. At the very top, we have strategic risk. These are externally driven forces. Think of things like market inflation, sudden pandemics, or shifts in government funding. These are risks you often cannot control, but you must prepare for. Next, we move down to program and subprogram risks. These deal with the connective tissue of construction, how different projects integrate and the dependencies between them. For instance, if Project A is delayed, does it starve Project B of materials? Then we arrive at project risk, which focuses on the specific scope of a single build. Finally, at the base of the pyramid, we have contractor risk. This is the ground-level reality of whether you have the right skills and resources available on site today. Understanding this hierarchy matters because you shouldn't use a contractor-level tool to solve a strategic-level problem. This brings us to a critical question. How much of this risk can your organization actually handle? Is there a difference between what you want to do and what you can afford to do? In the world of risk, we call this the balance between appetite and capacity. Think of risk appetite as your hunger for growth. It is your willingness to take on uncertainty to achieve a strategic objective. For example, a firm might have a high appetite for a complex bridge project because it wants to be known as the leader in innovative infrastructure. This is tied directly to your strategy and how you incentivize your team. On the other side of the scale, we have risk capacity. This is the hard ceiling. It is defined by your financial limits, your budget, and your capital structure. You might have a massive appetite for a project, but if a single failure would bankrupt the company, you lack the capacity to take it on. The core question every leader must ask is this course of action compatible with our risk appetite? You never want your appetite to outweigh your capacity, as that leads to catastrophic failure. With these limits in mind, let's look at how we can choose a delivery model that properly allocates these risks. The way you structure a contract is perhaps your most powerful risk management tool. It dictates who owns a problem when it arises. Let's look at 4 primary models. First, we have the traditional design bid build, or DBB. This is a sequential process where the owner holds the design risk. If the drawings are wrong, the owner pays. Next is design build, or DB. Here, the owner shifts risk to a single entity that handles both design and construction. This simplifies things for the owner, but puts a lot of pressure on the DB entity. Then we have construction management at risk, known as CMR. This involves the contractor early in the process, and they assume the construction risk at what we call a guaranteed maximum price, or GMP. Finally, there is integrated project delivery, or IPD. This is the most collaborative model, where everyone, the owner, designer, and contractor, shares both the risks and the rewards. Choosing the optimal model matters because it leads to increased profits and on-time completion. Now that we've seen how to allocate risk through contracts, let's look at the actual step-by-step process of managing it. Imagine trying to solve a puzzle without knowing what the picture looks like. That's what risk management feels like without a process. To bring order to the chaos, we use the Construction Industry Institute's CII 5-stage process. This is a continuous loop that ensures no risk is ignored. It begins with identification, simply listing what could go wrong. Once identified, we move to assessment and analysis. While these are distinct stages, you will often hear them referred to collectively as measurement. This is where we determine how big the risk is and how likely it is to happen. After we measure the risk, we move to mitigation. This is our action plan. How do we stop the risk or reduce its impact? Finally, we have the evaluation of results. This is a critical feedback loop. We look at whether our mitigation worked and then feed that information back into the identification stage for the next cycle. This matters because risk is dynamic. It changes as the project moves from design to the field. Let's take a closer look at that first crucial step. How do we actually find these risks? If you don't name a risk, you can't manage it. That's why Stage 1 risk identification is about filling the funnel. The ultimate goal here is to create a formal risk register, a comprehensive catalog of everything that could potentially impact the project's success. But where do these risks come from? We look at 3 main areas. First, we look at known issues. The things we already know are a problem, like a pending permit or a specific site constraint. Next, we lean on team experience. This is where your senior engineers and project managers say, on the last project in this region, we had trouble with this specific subcontractor. Finally, we use what-if scenarios to push our boundaries and imagine unexpected events. This methodology relies on collaborative brainstorming. It's not a solo job. It requires the situational awareness of the entire team to provide evidence and insights. Once we have this long list in our register, how do we decide which ones deserve our attention? We do that by looking at their likelihood. Not all risks are created equal. Some are 1 in a million shots, while others are practically guaranteed to happen. In Stage 2, we use a likelihood scale to rank them. This scale runs from level 1 to level 5. A level 1, or very low risk, is rare and has less than a 10% chance of occurring. Think of an earthquake in a non-seismic zone. At the other end, level 5 is very high, almost certain with a 90% or greater chance. This might be something like it will rain during the foundation pour in a tropical region during the wet season. In between, we have low, medium, and high levels that help us differentiate between things that are unlikely versus those that will probably happen. This matters because your time and money are limited. You cannot mitigate every risk with 100% effort, so you must prioritize. By assigning a numerical level and a percentage range, we move away from vague words like maybe and toward data-driven decision-making. Now, how do we turn these levels into actual numbers for our budget? We do that through analysis. Now we move from ranking to calculating. In Stage 3, we quantify the risk using 2 different methods depending on the quality of our data. First, there is deterministic analysis. We use this when we have reliable, known information. It uses a single-point estimate. For example, this delay will cost exactly $50,000. It's linear and straightforward, like a ruler. However, the built environment is rarely that simple. For complex or uncertain data, we use probabilistic analysis, often called a Monte Carlo simulation. Instead of one number, we use a range of possibilities to create a probability distribution. The output isn't a single point, it's a bell curve or an S-curve. This shows us the cumulative distribution of outcomes. For instance, it might show that there is a 25% chance the project finishes on time, but a 60% chance it finishes 2 weeks late. This matters because it gives stakeholders a realistic view of the most likely outcome versus the worst-case scenario. Once we know the numbers, we have to decide what to do about them. Once you've identified and analyzed a risk, you have to take action. This is Stage 4, mitigation. You have 4 primary strategies, plus a safety net. First, you can avoid the risk. This means changing your plans entirely to eliminate the threat. For example, choosing a different site to avoid a flood zone. Second, you can accept or retain the risk. This is common for small risks where you simply acknowledge they might happen and set aside a budget for them. Third, you can control or reduce the risk. This is the middle ground where you take steps to lower the likelihood of it happening or the impact if it does, like wearing PPE to reduce the impact of an accident. Fourth, you can transfer or deflect the risk. This is where those delivery models and insurance policies come in. You pay someone else to take the risk for you. Finally, we have contingency. This is the financial reserve you hold to cover risks that actually materialize. Choosing the right strategy matters because it determines your final project cost. To see which strategy to use, we can plot our risks on a matrix. How do you explain a complex risk register to a busy executive in 30 seconds? You use the PMI-CP matrix. This visual tool plots every risk based on 2 factors: likelihood on the vertical axis and impact on the horizontal axis. Likelihood is ranked 1 to 5, while impact is ranked A to E, from negligible to extreme. This creates a heat map. Risks in the bottom left blue area are low priority. They have a low chance of happening and wouldn't hurt much if they did. But as you move toward the top right, you enter the red zone. This is where you find risks with high likelihood and high impact. These are your project killers. The PMI-CP matrix matters because it forces an immediate decision. Any risk in that red zone requires immediate mitigation. It helps the team focus their energy where it is needed most. Now, let's see what this looks like when we put it all together into a working document. This is where the rubber meets the road. The detailed risk register is the living document that tracks everything we've discussed. Let's look at a real-world example in the table. Look at ID 2. B2. The event is political stability due to a new socialist parliament and mayor. Before we do anything, the team has assessed this as a likelihood of 4 and an impact of D. That's a major threat. Because this is a high-impact risk, we've chosen a transfer strategy by purchasing OPIC political risk insurance. This moves the financial burden away from our project, but look at the most important columns: owner and date. A risk without an owner is a risk that won't be managed. Paul Smith is the one responsible for making sure that insurance is in place by the specified date. This matters because it creates accountability. Without this level of detail, risk management is just a list of worries. But the process doesn't end once the register is filled out. It requires constant review. We've reached the final stage of the CII process: evaluation. Many teams make the mistake of treating the risk register as a one-and-done task at the start of the project. That is a recipe for disaster. Stage 5 is a continuous loop. We must constantly ask, has the risk status changed? Perhaps a risk we thought was a level 4 is now a level 2 because the situation evolved. We also ask, are the mitigations actually working? If we bought insurance but the policy has a loophole, our mitigation is failing. But risk management isn't just about avoiding bad things. We also practice opportunity management, or the identification of positive risks. These are events that, if they occur, would actually help the project, like a sudden drop in steel prices or an early permit approval. We use a similar matrix to track these. This matters because a good project manager doesn't just defend against threats. They actively hunt for opportunities to finish faster or cheaper. Now, as we wrap up, let's focus on the key concepts you'll need to remember for the exam. As you prepare to apply this in the field or sit for your certification, let's drill down on the essential definitions. First, never confuse appetite and capacity. Appetite is about your strategy. How much are you willing to risk? Capacity is about your bank account. How much can you lose? Next, memorize the CII process order. It always starts with identification and ends with evaluation. If you mix these up, your logic will fail. Also, be precise with your language. In this framework, likelihood often refers to the chance of a status change, while probability is the mathematical percentage. When we talk about analysis, remember that deterministic is a single number, while probabilistic uses Monte Carlo simulations to show a range of outcomes. Finally, understand your mitigation tactics. Transfer always involves a third party, like an insurance company or a subcontractor, while avoid requires a fundamental change to the project's scope. This matters because using the wrong term can lead to the wrong contract. Let's bring it all home with our final takeaways. We have covered a lot of ground today. If you take away only 5 things, let them be these. First, risk is an integrated responsibility. It is a team sport, and the delivery model you choose is the playing field. Second, always be aware of the perception gap. Your gut feeling is not a risk strategy. You must bridge the gap to actual risk with high-quality information. Third, use the 5-stage CII framework to ensure your control is standardized and repeatable. Fourth, don't just talk about risk, quantify it. Use the tools we discussed: risk registers, IPRA matrices, and Monte Carlo simulations to turn vague worries into actionable data. Finally, remember that knowing a risk isn't enough. You must act. Every risk needs a formal mitigation decision. Will you avoid, accept, reduce, transfer, or use a contingency? By applying these principles, you move from being reactive to being a strategic leader in the built environment. Welcome to this comprehensive session on managing one of the most challenging aspects of the construction industry, claims and dispute resolution. Have you ever wondered why even the most meticulously planned projects can end up in a heated legal battle over costs and timelines? In the built environment, conflict is often treated as an inevitable byproduct of complex engineering, but it doesn't have to be a project killer. Today we are moving beyond just fighting claims. We are going to explore a proactive framework focused on three distinct pillars. First, we look at prevention, how to stop a dispute before it even begins during the discovery phase. Next, we address mitigation, the art of reducing the impact of issues that have already surfaced. Finally, we will cover structural resolution, the formal mechanisms used to close out disagreements when informal talks fail. By the end of this module, you'll have a roadmap for protecting your project's bottom line and, perhaps more importantly, its professional relationships. Let's start by defining our learning objectives and what you should expect to take away from this training. What is the difference between a project that stays on track and one that falls into a claims trap? Usually it comes down to the team's ability to spot trouble before it arrives. Our first objective today is to dive into the root causes. We will identify the specific types of claims that plague the built environment and pinpoint exactly which front-end areas, the tasks we do before a single brick is laid, require the most scrutiny to prevent future headaches. Our second goal is to master a critical distinction, the difference between a change order and a contractual claim. While they might feel similar when you're looking at a budget overrun, they are fundamentally different in how they are managed and negotiated. One is bilateral and cooperative, the other is unilateral and often adversarial. Finally, we will focus on prevention and data. We'll discuss how to use historical project data and lessons learned from past failures to build a shield around your current project. This isn't just about theory. It's about using hard evidence to mitigate risks. With these objectives in mind, let's start with the basics. What exactly is the nature of a claim? Let's strip away the legal jargon for a moment. At its simplest, a claim is a formal cry for help or a demand for fairness. Technically speaking, it is a request by one party, usually the contractor, for compensation to cover damages caused by the other party's failure to meet their side of the deal. Think of it as the contract's built-in mechanism for rebalancing the scales of justice when something goes wrong. To understand how a claim is born, look at this four-step sequence. It starts with an event, perhaps a delay in site access. That leads to a failure to fulfill an obligation, such as the owner not providing the site on the promised date. This creates a detrimental effect, which in construction usually means extra costs or a delay in the schedule. Finally, this results in a formal request for compensation or an extension of time, often called an EOT. It's important to remember that most claims arise when an owner doesn't do what they specifically promised to do in the contract documents. If these requests aren't handled efficiently, they don't just go away. They escalate into expensive legal actions. To avoid that, we must understand how a claim differs from a standard change order. In the heat of a project, people often use the terms change order and claim interchangeably, but doing so is a dangerous mistake for any professional. A change order, or variation instruction, is a collaborative tool. It is bilateral, meaning both the owner and the contractor sit down and agree to modify the contract. Maybe you're adding a new wing to a building or resequencing the HVAC installation. Because it's a mutual agreement, the deadlines for these are often flexible and based on ongoing negotiations. A claim is a completely different animal. It is unilateral. This is one party standing their ground and demanding that the contract be enforced because the other side failed. Unlike the friendly negotiation of a change order, claims are governed by strict time bars. If the contract says you must give notice of a claim within 14 days and you do it on day 15, you might have just lost your right to be paid entirely, regardless of how right you are. Think of a change order as a handshake and a claim as a legal summons. Understanding this distinction is vital because in the world of claims, the clock is always ticking. Let's look at those time bars in more detail. If there is one concept that keeps construction lawyers busy, it's the time bar. We often call this the kill switch for claims. Why? Because in many jurisdictions and under most standard contracts, if you fail to provide written notice within a specific window, your right to claim compensation is legally dead. It doesn't matter if the owner's mistake cost you $1 million. If you miss the window, you've likely lost the money. Let's look at a common example using the AIA, or American Institute of Architects, standard. Usually, day 0 is the moment the event occurs, or the moment you first realize there's a problem. Under AIA standards, you often have a 21-day notice window. You must get that claim in writing and onto the owner's desk before day 21. If you wait until day 22, you are time barred. This is why documentation is so critical. You cannot rely on a verbal, "we'll take care of it later" in a meeting. Without a written trail within that 21-day window, your legal rights are effectively erased. Now that we know how to file, let's look at the different legal categories these claims fall into. Not all claims are created equal. To resolve them, you must first know which bucket they fall into. The most common are contractual claims. These are the easiest to manage because they are rooted in the specific language of your agreement. If Clause 4.2 says the owner must provide site access by June 1st and they don't, you have a direct contractual path to a claim. Then, we have extra contractual claims. These are a bit more complex because there isn't a specific clause covering the event, but there has been a fundamental breach of contract. For example, if the owner supplies defective materials that weren't explicitly detailed in a clause but clearly prevent you from working, you are claiming based on the implied duty of the owner to cooperate. The third type, ex gratia claims, are the Hail Marys of the industry. These have no legal or contractual basis. They are made on moral grounds. For instance, asking for more money because hyperinflation has made your original bid impossible to live by. Finally, we have the EOT, or extension of time. These are purely schedule-based. If no completion date was ever set, the law generally implies that the work must be done in a reasonable time. Identifying which of these you are dealing with is the first step in our next topic, the top 10 most common claim types. To prepare for battle, you need to know where the attacks usually come from. Based on the HKA Crux Insight report, which analyzed over $1 trillion in project value, we've identified the most frequent culprits. The first category is financial and schedule-based. Payment-related claims are the most immediate. This includes non-payment, late checks, or those frustrating mystery deductions where an owner keeps a portion of the invoice without explaining why. Next are change claims. These happen when the owner revises the scope midstream. Even a small change in a blueprint can have a massive ripple effect on the total cost and the sequence of work. Then, of course, we have the classic delay claims. These involve unexpected circumstances that keep your crew sitting idle. Think of severe weather events, or the owner failing to get the necessary permits for site access. Finally, we see frequent disputes over pricing and measuring. This is often a math war, where the contractor and owner disagree on the final quantity of materials used, or the specific unit rates applied to extra work. These are the bread and butter of construction disputes, but as we'll see in part 2, the issues can get much more technical. Moving into part 2 of our top 10, we look at claims that arise during the actual execution of the work. Extra work is a major flashpoint. This happens when a clarification from the architect is interpreted by the contractor as a whole new task that wasn't in the original bid. Closely related are site conditions claims, the classic differing site conditions scenario, where you dig a hole and find a rock formation or a utility line that wasn't on the drawings. Another high-pressure area is acceleration. This occurs when the project is behind schedule, often due to no fault of the contractor, and the owner orders you to hire extra crews or work double shifts to hit the original deadline. Who pays for that extra labor? That's a claim. We also see damage claims for property or safety issues, and contractual ambiguity claims, which are essentially arguments over who was supposed to be responsible for a specific risk. Finally, we have termination claims. These are the most severe, involving the total breakdown of the relationship and the contractor seeking to recover the income they lost because the project ended early. Termination is a nuclear option in construction, and it's worth looking at the specific scenarios where it happens. When a contract is terminated, the financial cleanup depends entirely on when the plug was pulled. It's a sliding scale of recovery. If the owner terminates the contract before work starts, the contractor hasn't spent much on labor yet, but they've missed out on a major opportunity. In this case, the contractor is generally entitled to recover their loss of expected profit. Alternatively, they might claim the difference between the total contract price and what it would have actually cost them to do the work. If the termination happens, after work starts, the calculation gets more granular. The contractor needs to be made whole for the work they've already performed, plus any costs associated with shutting down the site, such as demobilizing equipment or canceling subcontracts. Finally, if the work is completed and compliant, but the owner tries to terminate or refuses to pay at the very end, the contractor is simply entitled to the full contract price. Each of these scenarios carries heavy financial weight. To put this in perspective, let's look at the actual dollar amounts involved in global construction disputes. If you think claims are just a minor administrative annoyance, these numbers from Arcadis should change your mind. The cost of conflict in our industry is staggering. On a global scale, the average value of a single construction dispute is over $30 million. In North America, we've seen mega disputes reach as high as $1.5 billion. When you realize that the data we're looking at comes from a pool of $1.2 trillion in analyzed project spending, you see that this isn't a niche problem, it's a systemic one. The most worrying trend isn't just the dollar amount, it's the duration. Litigation is taking longer, and as it drags on, costs skyrocket and professional relationships are permanently destroyed. This is why the industry is shifting toward early settlement. The goal now is to resolve the friction before it turns into a fire. To do that, we have to understand the ripple effect of how a tiny misunderstanding grows into a multi-million-dollar claim. Disputes don't happen in a vacuum. They follow a predictable, destructive path that we call the ripple effect. It almost always starts with an undefined risk, something in the contract that was vague or a responsibility that no one wanted to claim. This ambiguity inevitably leads to conflict, which is characterized by simple misunderstandings of who was supposed to do what. If that conflict isn't managed immediately, it moves to the next stage: strained relations. This is where the erosion of trust happens. Once the parties stop trusting each other, they stop communicating effectively. This creates a fertile ground for the final stage: formal disputes and claims. At this point, the handshakes are over, and the formal demands start flying. What feeds this ripple effect? Common culprits include errors and omissions in the contract documents, a failure of the team to actually read and comply with their obligations, and, perhaps most common, unrealistic completion dates that were doomed from day one. To break this cycle, we need to look at the entire contract life cycle. To manage claims effectively, you have to know which zone you are in. We divide the project lifecycle into two main areas. The first is the prevention zone. This happens at the very beginning, during discovery and the pre-award phase. This is your golden opportunity. Any work you do here to clarify the scope or fix contract language is 1,000 times cheaper than fighting a claim later. The second area is the mitigation zone. Once the contract is awarded, and we move into the proposal process and then into execution and management, we are no longer in prevention mode. We are in damage control. Here, the goal is to stop existing issues from escalating. Finally, we have contract closeout, where we settle any remaining disagreements. The key takeaway here is that your power to prevent claims is highest at the start and drops off sharply once the work begins. Let's look specifically at what happens in Stage 1, prevention. To manage claims effectively, you have to know which zone you are in. We divide the project lifecycle into two main areas. The first is the prevention zone. This happens at the very beginning, during discovery and the pre-award phase. This is your golden opportunity. Any work you do here to clarify the scope or fix contract language is 1,000 times cheaper than fighting a claim later. The second area is the mitigation zone. Once the contract is awarded and we move into the proposal process and then into execution and management, we are no longer in prevention mode. We are in damage control. Here, the goal is to stop existing issues from escalating. Finally, we have contract closeout, where we settle any remaining disagreements. The key takeaway here is that your power to prevent claims is highest at the start and drops off sharply once the work begins. Let's look specifically at what happens in Stage 1, prevention. Prevention is the most cost-effective form of dispute resolution. It happens during the discovery and pre-award phase. The goal here is alignment. To get there, your inputs must be solid. You need a rigorous scope assessment to make sure everyone agrees on what is being built. You need a governance agreement, essentially a rulebook for how decisions will be made. And most importantly, you need a fair risk-sharing arrangement. If you try to push all the risk onto the contractor, you aren't preventing a claim. You're just delaying it. In terms of best practices, you should be leveraging your Project Management Information System, or PMIS, to ensure every document is trackable from day one. You also need a training plan, so the field team actually understands the contract they are working under. Finally, look at lessons learned from your previous 5 projects. If you keep having the same dispute over and over, the problem is in your process. The desired outcome of this stage is simple: a project where the risks are clearly distributed and the errors in the documents are eliminated before the first shovel hits the ground. But what if prevention isn't enough? That brings us to mitigation. Mitigation is about amicable resolution. It starts at the pre-award phase, but continues all the way through execution. Think of this as the safety net for when problems inevitably occur. One of the most powerful inputs here is the Dispute Review Board, or DRB. This is a panel of neutral experts who stay with the project from start to finish. If a conflict arises, they give a non-binding recommendation immediately, often preventing a formal claim from ever being filed. To succeed in mitigation, you must master the best practices of documentation. This means having a time-bound RFI procedure. If an architect takes 30 days to answer a simple request for information, RFI, they are practically inviting a delay claim. You also need impeccable change order documentation. The desired outcome here is to take those unilateral claims we talked about earlier and convert them into bilateral change orders. We want to reach an agreement while the project is still moving, rather than waiting for a courtroom 2 years later. A huge factor in your ability to do this is the delivery method you choose. The way you structure your project team, your delivery method, is perhaps the biggest predictor of claim frequency. Let's look at the spectrum. On one end, we have Design Bid Build, or DBB. This is the traditional sequential approach. Because the design and construction are under separate contracts, there is often a massive misalignment. The contractor blames the designer for errors. The designer blames the contractor for poor execution. This method historically has the highest rate of claims. On the other end, we have Integrated Project Delivery, or IPD. This is a collaborative all-for-one structure, where the owner, designer, and contractor share both the risks and the rewards. When a problem occurs, the team works together to fix it because their profit is tied to the project's success, not just their own. In between, we have Design Build, which provides a single point of responsibility to reduce finger-pointing, and CM at Risk, where a construction manager accepts the risk for the schedule and price via a Guaranteed Maximum Price, GMP. If you want fewer claims, you move toward collaboration. This philosophy is often called partnering. Partnering isn't just a feel-good buzzword. It's a rigorous business strategy that originated at DuPont Engineering in the 1980s. The core idea is to shift the project culture from adversarial to mutual. In a traditional setup, parties focus on winning the argument, proving the other guy is wrong so they don't have to pay. Partnering shifts that focus to project success. This doesn't mean you ignore the contract. It means you agree how you will handle disagreements before they happen. As you can see from our fit analysis, partnering is a natural fit for collaborative methods like IPD and CMAR. It is much harder to implement in a traditional design bid-build environment because the contracts themselves are designed to keep the parties at arm's length. When partnering fails or when no collaborative framework exists, we have to move up the escalation ladder. When a claim cannot be settled on the job site, we enter the formal resolution process. Think of this as an escalation ladder. You want to stay on the bottom rungs as long as possible. The first rung is negotiation, direct, face-to-face communication. This is where the vast majority of issues should be resolved. If that fails, we move to mediation, where a neutral third party helps the sides reach their own agreement. It's important to note that mediation is non-binding. The mediator can't force you to settle. If the disagreement continues, we move to adjudication or a dispute review board, DRB, which provides a more formal decision. Then we hit the binding rungs. Arbitration is a private process where an arbitrator makes a final legal decision that both sides must follow. Finally, at the very top of the ladder is litigation, a public court battle. This is the most hostile and expensive option. As you move up this ladder, the cost, the time, and the blood pressure of everyone involved increase exponentially. Our goal as professionals is to keep our disputes at the negotiation level. If you are preparing for a certification or high-stakes project review, these are the high-yield concepts you must memorize. First, never forget the DNA of the documents. A claim is a unilateral demand, while a change order is a bilateral agreement. Second, respect the time bar. In the AIA world, that 21-day window is a hard wall. If you hit it, you're out. Regarding termination, know the difference between for convenience, where the owner just decides to stop and owes you the price for your readiness, and for cause, where someone messed up and is now liable for damages. Also, if you're asked what the #1 cause of construction disputes is, the answer isn't bad weather or expensive materials. It's the miscommunication of obligations. People simply don't understand what they signed up for. Finally, remember our timing. Prevention happens before the award. Mitigation happens after. Let's wrap this up with our key takeaways. We've covered a lot of ground today, from the legal definition of a claim to the staggering costs of litigation. If you take away only 5 points, let them be these. First, integration works. Moving toward collaborative methods like IPD and CMAR is the most effective way to lower your claims profile. Second, you must be proactive. You cannot wait for a dispute to settle itself. It won't. It will only escalate. Third, documentation is your armor. In a dispute, he who has the best records wins. Use your PMIS to keep a clean, trackable trail. Fourth, seek alignment. Ensure that the incentives of the owner, contractor, and designer are pointed in the same direction. And finally, remember the golden rule of claims. Your greatest power to protect your project ends the moment the contract is awarded. Everything after that is just damage control. Now, let's open the floor for our Q&A session. Welcome to Lecture 19. Have you ever noticed that on large-scale construction projects, the most expensive delays rarely happen in the middle of a contractor's work, but rather at the edges where two different contractors meet? This white space between scopes of work is where the most significant risks hide. Today, we are beginning our deep dive into interface management fundamentals. As part of your PMI-CP exam preparation, this domain is crucial because it focuses on the connective tissue of a project. Think of interface management not just as a set of meetings, but as the rigorous discipline of managing the boundaries. In this session, we will move beyond simple coordination and into a structured framework that ensures different project elements integrate seamlessly. Whether you are a project manager, a lead engineer, or a construction executive, mastering these fundamentals is the first step toward preventing scope gaps and integration failures. Let's start by defining our path forward and the specific objectives we will hit today. What does it take to actually manage an interface in the eyes of the PMI? It starts with understanding the hierarchy. By the end of this module, you'll be able to clearly define the relationship between stakeholders, interface points, agreements, and action items. This hierarchy is the backbone of the entire process. We will also analyze the Master Interface Plan, or MIP. This isn't just a document that sits on a shelf. It is a strategic tool for proactive risk mitigation. Furthermore, we are going to look at conflict. When two contractors disagree, how do you use formal governance logic to find a solution? You'll learn to evaluate specific exam scenarios to determine which tool is right for the job. Is it an interface register, a formal agreement, or a technical control document? Pay close attention to the exam focus here. The PMI-CP exam cares deeply about the order of operations. It's not just about doing the right thing, it's about doing it in the right sequence and with the right level of formality. Let's look at the why behind this shift in project management strategy. Why has interface management become a standalone domain in project management? The answer lies in the evolution of our industry. Construction projects have shifted from localized, simple scopes to massive global mega projects. In the past, you might have managed a handful of local subs. Today, you are likely dealing with multiple vendors and teams spread across different continents. This geographical and organizational dispersion creates a massive risk of scope gaps. The problem we face is that informal coordination, the old-fashioned way of managing via spreadsheets and a mountain of emails, is no longer sufficient. It's too easy for critical details to fall through the cracks. The solution is interface management. It provides a controlled environment where every discussion is documented and assessed. This isn't just a theoretical benefit. Research from the Construction Industry Institute, or CII, shows that effective interface management leads to much higher stakeholder alignment and prevents risks from turning into expensive field changes. Now let's get into the technical definitions you'll need for the exam. To master this domain, we must be precise with our terminology. Interface management is defined as the management of communications, relationships, and deliverables among two or more interface stakeholders. Notice that it's not just about the technical stuff. It's about the people and the communication as well. We categorize these boundaries into two main types: internal and external. An internal interface occurs within a single contract. It might be two different departments in the same company working on the same project. However, the external interface is where the most significant risks lie. This is the boundary between two different contracts, say, a civil contractor and a mechanical contractor. Because these are separate legal entities, there is no direct line of authority between them. This is a major exam focus point. External interfaces always require a higher level of formal governance because they are the most likely source of disputes and integration failures. If an exam question asks you to prioritize, always look toward the external boundaries first. Let's break down the Level 1 hierarchy. It starts with the interface stakeholder. This is simply the entity that owns a particular scope of work. When two of these stakeholders have scopes that meet, we identify an interface point, or IP. Think of the IP as the exact location or moment where responsibility is handed off. For example, if you are building a tunnel, the IP is the exact point where the civil contractor's structural concrete ends and the mechanical contractor's ventilation mounting begins. This is a physical boundary, but it can also be a functional one. To keep track of these, we use a vital tool, the interface register. This is a central live document where every single identified IP is logged. If you don't identify the point first, you can't manage the relationship. On the exam, remember that identifying the IP is the foundational step. You can't have an agreement or an action item until you have defined exactly where that point of connection is. Now that we have identified our point, we move to level 2, the interface agreement, or IA. If the IP is the where, the IA is the what, when, and who. It is a formal, documented commitment between stakeholders. It describes exactly what is being delivered, the deadline for that delivery, and the specific people responsible. A single interface point might have several agreements associated with it over the life of a project. Beneath the agreement, we have level 3, the interface action items, or IAIs. These are the actual tasks that need to be completed to fulfill the agreement. For instance, if the agreement is to provide structural load specs, the action item might be engineer Smith to complete the calculation by Friday. Here is the critical logic you need for the exam. You cannot have a formal agreement until you have a point. The sequence is non-negotiable. Point leads to agreement, and agreement leads to action. This ensures that every task being performed is anchored to a formal project boundary. When we move into the technical design phase, we need a specialized tool called the Interface Control Document, or ICD. While an agreement deals with the business of the handoff, the ICD deals with the physics of it. It consists of the actual drawings and specifications that capture how two systems will physically connect. This is absolutely critical when you have different organizations designing parts of a project simultaneously. If contractor A is designing a pump and contractor B is designing the piping, they both must reference the same ICD to ensure the flanges actually match up on site. The ICD is also the home for change management. Any approved interface change requests must be updated here. Here is an insider tip for the exam. If you see a question about separate organizations developing design solutions or a scenario involving physical mismatches, your mind should jump immediately to the ICD. It is the technical source of truth for the interface. Above all the individual points and agreements, we have the Master Interface Plan, or MIP. Think of the MIP as the rules of the road for the entire project. It is a strategic document that outlines exactly how interfaces will be managed. It defines the communication protocols, the software to be used, and the escalation paths for when conflicts arise. One of the most important functions of the MIP is that it mandates face-to-face meetings. In large projects, it's very easy for teams to fall into siloed working, where they never talk to the people across the boundary. The MIP prevents this by building trust and alignment through regular interaction. From a risk perspective, the MIP ensures that interfaces are identified early, specifically during front-end planning or FEP. The goal is to find the clashes on paper months before they become expensive problems in the field. Let's see how this all looks in a real-world scenario. Let's apply these concepts to a metro station project. We have a civil contractor building the walls and a systems contractor installing the ventilation. First, we identify the interface point, the actual mounting brackets that need to be embedded into the tunnel wall. This is where the two scopes meet. Next, we establish the interface agreement. The systems contractor agrees to provide the load specifications by April 1st, and the civil contractor agrees to have those specific brackets installed by June 1st. This manages the schedule and the handoff. Finally, we use an interface control document, in this case, drawing E204. This drawing shows the exact bolt pattern for the brackets. If the civil contractor just guesses where the holes go, the ventilation fans won't fit, and we'll have a major delay. By using the IP, the IA, and the ICD together, we ensure a perfect fit on the first try. Now, let's look at a scenario you might encounter on the exam. Imagine during the execution phase, contractor A is stuck. They can't finish their piping design because contractor B hasn't provided the pump flange specs. Contractor B argues that they were never formally asked for that specific detail. They thought the general arrangement was enough. A schedule delay is now imminent. What should the project manager have done to prevent this? While an ICD shows technical details, the dispute here is about a missing deliverable and a timeline. Therefore, the correct answer is an interface agreement, or IA. An IA is specifically designed to document deliverable descriptions, due dates, and required actions. It takes the ambiguity out of the relationship. If there's a signed IA that says, Contractor B provides flange specs by March 10th, there is no room for argument. Here is another common scenario, a soft conflict. We have two contractors in a joint venture who are arguing daily over space in a utility corridor. They are sending dozens of conflicting emails, and no one knows what the current agreement actually is. What is the first action the project director should take? The answer is to implement an interface register. The root cause of this chaos is the lack of a controlled environment. Without a central repository, communication becomes a game of he said, she said. By mandating the use of a register, you create a single source of truth. Every conflict, every agreement, and every spatial requirement is logged in one place for everyone to see. This forces consistency and stops the email wars. On the exam, if you see a situation involving unorganized or conflicting communication, the register is almost always your first step toward a solution. When you're answering exam questions, you need to use risk-based decision logic. There are three key patterns to look for. First is timing. The PMI-CP exam expects you to identify interfaces during the planning phase, or front-end planning. If a scenario suggests identifying them during construction, that's usually a sign of a failed process. Early identification is the only way to mitigate risk effectively. Second, look at the tools. For a global mega project, manual tracking, like a simple Excel sheet, is often considered the wrong answer. You should look for options that mention automated systems or interface management systems. Finally, don't ignore the soft interfaces. Relationships and communication protocols need to be managed just as rigorously as the hard physical connections. If you manage the bolt pattern but ignore the contractor relationship, the project will still suffer. Always choose the most proactive and formal management option. Let's highlight some traps to avoid. One of the biggest is the spreadsheet mentality. Many project managers think they can handle thousands of interface points with a simple list. On large projects, this leads to disaster. Another common mistake is ignoring the ICD. This happens when engineers work in isolation, assuming their part of the design will magically fit the others. We also see late identification far too often. If you are defining an interface while the contractor is standing on the job site with a crane, you have missed the window for risk mitigation. Finally, never confuse internal and external interfaces in terms of risk. External interfaces carry a much higher risk of litigation and delay. If you treat an external boundary with the same low level of formality as an internal one, you are inviting conflict. The exam will test your ability to recognize these lapses in rigor. As we conclude, let's recap the vocabulary of interface management. This is your mental checklist for the exam. We start with IM itself, the high-level management of communication, relationships, and deliverables. Then we have the IP, the physical or functional point where things meet. From that point, we generate an IA, the agreement that defines the who, what, and when. Supporting that agreement are the IAIs, or action items, the tasks that produce the results. On the technical side, the ICD is the document that ensures everything fits. And finally, the MIP is the master plan that provides the overarching strategy. If you can keep these terms and their relationships clear in your mind, you'll be able to navigate any scenario the exam throws at you. To finish up, here are 4 final tips for your exam. First, hierarchy is everything. Never try to draft an agreement before you have identified and logged the interface point. Second, formalize everything. In a controlled environment, informal agreements don't count. If it's not in the register, it doesn't exist. Third, prioritize your external interfaces. These are where the greatest risks to your budget and schedule reside. Finally, remember that interface management is a tool for planning. If you only use it when a problem arises in execution, you're just troubleshooting. You're not managing the interface. Stay proactive, stay formal, and follow the hierarchy. In our next lecture, we'll take these fundamentals to the next level with advanced interface configuration management. Why do even the best planned projects, like this massive bridge, go off track with delays and cost overruns? It's rarely a single failure. More often, it's what happens in the spaces between, where teams, scopes, and systems connect. That's where interface risk lives. In this course, we explore interface management, IM, a strategic approach to managing handovers and boundaries in complex built environment projects, from civic infrastructure to industrial energy plants. IM is the glue that holds fragmented, multi-billion-dollar projects together. It's not a one-time task. It's a continuous effort across the entire life cycle, from design to delivery. We'll define what an interface really is, explore proven tools to assess your organization's readiness, and give you a roadmap to reduce friction and improve coordination. Let's start with the core methodology that brings order to the chaos. Imagine a project where every contractor uses a different communication software, different naming conventions for their blueprints, and a different schedule for progress reports. It sounds like a nightmare, doesn't it? That is exactly what we avoid by implementing a formal methodology for interface management. The ultimate goal here is to allow projects to standardize their processes, tools, and templates. By doing this, we don't just talk more. We optimize communication so that the right information reaches the right person at exactly the right time. Our methodology follows a 4-stage workflow: standardize, assess, prioritize, and execute. First, we standardize. We do this by implementing the IM maturity model throughout the entire project lifecycle. Think of this as a health check for your project's organizational structure. It ensures that before the first shovel hits the ground, the rules of engagement are set and every party is working from the same playbook. Next, we move to the assess phase. Here, we utilize a strategic tool called the Project Interface Risk Impact Matrix, or the PMI matrix. This is a high-level decision tool used to determine just how much management your project actually needs. Is a simple spreadsheet enough, or do you need dedicated interface managers and commercial software? The PMI matrix gives you that answer. Once we know the overall risk, we must prioritize. No project has infinite resources, so we use the Interface Complexity Assessment Tool, or ICAT. This tool helps us identify specific interface points, the actual physical or functional boundaries between stakeholders, and determines which ones are the most complex. If 2 contractors are working on a highly technical tie-in for a high-pressure gas line, ICAT helps us flag that as a high-priority interface. Finally, we execute. This is the boots-on-the-ground phase where we monitor ongoing work to minimize risk and manage the high volume of contractors typically found on modern sites. By following this structured path, we move away from reactive firefighting and toward proactive management. Now that we understand the process, let's look closer at how we actually define these connections between project parties. In technical work, we often think of an interface as a point where pipes meet or code connects. But in interface management, it's broader and more human. An interface is any point where one party depends on another for data, access, or task completion. Look at the hub and spoke model on this slide. At the center, the project. Around it, 5 key players: organizations, clients, contractors, suppliers, and subcontractors. Every interface between them represents a shared responsibility, not just a connection. Take a supplier-contractor interface. It's not just a delivery date. It includes specs, site requirements, and quality docs for client approval. If any part is missed, the project suffers. Why does this matter? Because these groups often have conflicting goals. Clients want low cost, high quality. Subcontractors want speed. Interface management helps bridge these gaps by documenting interdependencies with precision. Defining an interface means party A gives item X to party B by date Y, and here's how we both agree it's done right. This kind of clarity stabilizes projects, but identifying interfaces isn't enough. Next, we'll look at the critical success factors that make them actually work. What separates a project that finishes strong from one that falls apart? It often comes down to 3 critical success factors: deliverables, roles, and information flow. If anyone is unclear, the interface will fail, bringing rework, delays, and disputes. 1. Deliverables. You must define exactly what's being exchanged. A preliminary drawing mistaken for a final one can cost millions. In interface management, a deliverable isn't just a file, it's a fully scoped, maturity-defined package. 2. Roles and responsibilities. "I thought you were doing that" is deadly. Responsibilities must be explicit and accountable. Use tools like the RACI matrix to define who's responsible, accountable, consulted, and informed for every handoff. 3. Information flow. Information is the project's lifeblood. It must be clear and fast. Delays in communication, especially with design changes, can be catastrophic. Field teams need real-time updates, not stale reports. These 3 don't work alone. They need an enabling mechanism, advanced systems like BIM or IPD, and digital platforms that provide full traceability. You need to know who sent what, when, and who approved it. Now that we know what makes an interface succeed, how do we get everyone to formally agree? A common mistake in project management is trying to use a cookie-cutter approach for every job. But we know that every built environment project is unique. The soil conditions change, the local regulations vary, and the mix of subcontractors is never the same. Because of this uniqueness, we must perform specific assessments to adopt interface management as a standardized approach for each specific project. This is the agreement phase, where everyone signs off on how the interfaces will be handled. There are several key aspects that the project leadership must review and agree upon before work begins. First, we need to finalize interface identification. This means creating a master list of every point where 2 parties meet and assigning specific deliverables to those points. We also need to define the specific roles and responsibilities for the management of those points. Who is the owner of the interface and who is the requester? Next, we define the IM processes. This includes the technical information flow. How do we request information? How do we provide it? We also establish the coordination mechanisms, such as weekly interface meetings or shared digital environments. Crucially, we must agree on issue resolution. When 2 contractors disagree on a physical connection point, what is the escalation path? How quickly must a decision be made? We also set the schedules for interface requests and closeouts. An interface is not finished until it is formally closed out in the system, ensuring that all data has been handed over and the physical work is verified. Think of this slide as the blueprint for your management system. If you haven't checked off these items on your assessment checklist, your project is at risk. But what exactly are those risks? Let's look at the common issues that plague projects when these agreements aren't in place. Why do we go through all this effort? Because the cost of ignoring interface management can be massive. On large projects, 4 risks come up again and again. First, sheer volume. More subcontractors means more interfaces and more complexity. Second, the human factor. Many teams haven't worked together before, leading to misalignment. Third, unclear scope. When responsibilities aren't crystal clear, tasks fall through the cracks. Fourth, slow decisions. Without a defined process, small issues lead to big delays. And the result? Mismanagement. Delays, cost overruns. Soft coordination problems become hard financial pain. To prevent that, we need a way to measure our readiness. That's where the interface management maturity model comes in. To solve the risks we just discussed, we turn to a specialized solution, the Interface Management Maturity Model. This model was developed by the Construction Industry Institute, or CII, which is a consortium of leading owners, engineering contractors, and suppliers. They recognize that projects need a structured, scientific way to assess whether they are actually ready to manage complex interfaces. The primary purpose of this model is to provide a framework for implementing IM best practices. It's not just a set of rules, it's a maturity scale. Just as a person matures through different stages of life, a project organization can move from ad hoc and disorganized to optimized and highly efficient. By using this model, project leaders can objectively look at their organization and say, we are great at the technical side, but our cultural behaviors for collaboration are immature. The greatest benefit here is early intervention. By assessing maturity during the front-end planning phase, represented by the foundation pouring we see on this slide, project professionals can identify potential risk sources before they become embedded in the project. If you identify a gap in your maturity early, it is relatively easy and cheap to mitigate. If you wait until the steel is being erected, fixing a process gap becomes incredibly expensive. In essence, the maturity model helps you build the foundation of your management system. It ensures that the project isn't just lucky, but is structurally sound from a management perspective. But what exactly is the model looking at? What are the ingredients of a mature IM system? Let's break down the 4 core elements that define maturity. What does maturity actually look like in practice? The CII model breaks it down into 4 interconnected elements. Think of these as the 4 pillars supporting your project's stability. If one is weak, the whole system can lean or collapse. The first pillar is business processes. These are the documented procedures, the how-to guides, at both the company and project level. A mature organization doesn't rely on the memory of a senior project manager. It has written workflows for how an interface is identified, tracked, and closed. The second pillar is enabling tools and systems. In the digital age, managing 5,000 interfaces with just sticky notes and emails is impossible. This element looks at the software and IT systems you have in place. Are you using a dedicated interface management system? Or are you trying to force a standard document control system to do the job? Mature projects use tools specifically designed to handle the multi-party workflows of IM. The third pillar is qualified people. You can have the best software in the world, but it won't work without skilled practitioners. This includes the sponsors, the high-level leaders who provide the budget for IM, and the adopters, the engineers and managers who use the system daily. Maturity means your team actually understands the value of IM and has the training to execute it. Finally, we have the most elusive but important pillar, sustaining culture. This refers to the behaviors of the team. Is IM a routine part of the day, like a safety briefing, or is it seen as a burdensome extra task? In a mature culture, collaboration is the default mode, and transparency is valued over hiding mistakes. When these 4 elements, process, tools, people, and culture, are aligned, you have a high level of interface management maturity. But how do we get from where we are today to that ideal state? We use a process called gap analysis. Achieving maturity isn't something that happens overnight. It's a deliberate journey. As shown in the staircase visual on this slide, we begin at our current state and aim for a desired state. The mechanism that moves us up those stairs is the gap analysis. First, we must define our current state. This involves looking at the specific project on the horizon and asking, what are the anticipated IM requirements for this job? We look at our existing staff, our current software, and our previous experience. This gives us a baseline, an honest look at what we are capable of right now. Next, we define the desired state. This isn't just about being better. It's about meeting the specific needs of the project portfolio. We look at the potential interface risks and the consequences of failure. If the project is a standard commercial office building, our desired state might be relatively simple. But if the project is a nuclear power plant or a deepwater oil rig, our desired state must be much higher on the staircase because the consequences of an interface failure could be catastrophic. The gap is the space between these 2 points. Our gap analysis asks, what are we missing? Do we need to hire a dedicated interface manager? Do we need to purchase commercial IM software? Do we need to rewrite our project execution plan? By identifying these gaps early, we can create a targeted action plan to climb the stairs. This prevents us from overinvesting in tools we don't need or underinvesting in processes that are critical. Now, to help us determine exactly where that D. Every project manager eventually asks, how much interface management is enough? You don't want to over-engineer a simple project with expensive software, but you can't afford to undermanage a complex one. This is where the Project Interface Risk Impact Matrix, or PIRE matrix, becomes your best friend. It is a strategic, high-level decision tool recommended by the Construction Industry Institute. The PIRE matrix helps you identify the formality of the IM system you need. It works on 2 axes. The vertical axis measures the overall project interface complexity and risk level. Is the project technically difficult? Are there many first-time technologies? Are there dozens of contractors working in a small space? The higher the risk and complexity, the higher you move on this axis. The horizontal axis measures the business impact on the organization. This is the strategic side. If this project fails, does it bankrupt the company? Does it ruin your reputation with a major client? Is it a flagship project for the firm? By plotting your project on these 2 axes, you land in a specific cell that tells you how formal your management needs to be. For a low-risk project with low business impact, an informal system using basic spreadsheets might be perfectly fine. But as you move toward high complexity and high impact, the PIRE matrix will guide you toward a most formal system. This is a critical distinction in the exam and in professional practice. PIRE is a macro tool. It looks at the project as a whole from an organizational perspective. It doesn't tell you how to manage a specific pipe connection. It tells you how to set up the entire management department. Let's look at what the actual matrix looks like and the specific recommendations it provides. Now we see the PIRE matrix in its full detail. This visualization is essential for deciding your resource allocation. Notice how the requirements for people, tools, and processes evolve as the complexity and business impact increase. If your project falls in the low complexity, low impact zone, the bottom left, the recommendation is informal IM. Here you might only need a partial interface manager, someone who does IM as 20% of their job, and a basic spreadsheet to track handovers. It's light, it's cheap, and for a simple project, it's effective. As you move into the medium zones, we transition to formal IM. Now, the recommendations become more stringent. You likely need a full-time interface manager and a comprehensive spreadsheet. You might even start using partial commercial software, perhaps for certain high-risk technical areas to ensure nothing falls through the cracks. The top right of the matrix represents the high complexity, high impact projects. This is where most formal IM is required. We are talking about a dedicated interface manager whose only job is managing boundaries. You need full-scale commercial IM software that is designed for this purpose. Crucially, look at the integration bullet points. You need full integration with the project schedule and the risk management system. If an interface is delayed, it should automatically trigger a red flag in the master schedule. This matrix prevents the Goldilocks problem. It helps you find the level of management that is just right. If you use an informal system for a high-risk project, you'll face the cost escalations we discussed earlier. If you use a most formal system for a simple project, you're wasting money on overhead. Once you've used the PMI matrix to find your cell, what do you do with that information? Using the PMI matrix isn't just a theoretical exercise. It leads directly to an operational action plan. There is a 3-step process for applying these results to your project setup. Step 1 is to match your project to a PMI cell. This requires an honest, data-driven assessment of your project's risk and its business importance. Don't do this in a silo. Involve your technical leads and your executive sponsors to ensure the business impact is correctly understood. Step 2 is to determine requirements. Once you have your cell, let's say it's more formal IM, you look at the specific resource correlations. Do you need a dedicated interface manager? Does the PMI matrix say you need full integration with change management? This step tells you exactly what ingredients you need to buy or build. Step 3 is to create the action plan. This is where we align our requirements with the maturity elements we discussed earlier. If the PMI results say we need commercial software, our action plan must include a line item for software procurement and training. This addresses the enabling tools and qualified people elements. If the results require integration with the schedule, we must update our business processes to reflect that new workflow. This matters because it creates a direct link between the risk of the project and the resources assigned to it. It ensures that the project team has the institutional support they need to succeed. But remember, PMI is the big picture. It tells us the level of formality for the whole project. To get down into the nitty-gritty of specific relationships between two contractors, we need a different tool. Let's look at the tactical counterpart to PMI, the ICAT. If the PMI matrix is our telescope looking at the entire project from a distance, the Interface Complexity Assessment Tool, or ICAT, is our microscope. While PMI is a high-level strategic tool, ICAT is a tactical, hands-on resource, usually a specialized Microsoft Excel-based tool that looks at the specific puzzle pieces of your project. The primary function of ICAT is to prioritize the interfaces between specific pairs of stakeholders. For example, you might use ICAT to evaluate the relationship between the turbine manufacturer and the civil works contractor. These two parties have a very specific set of handovers. The civil team needs the anchor bolt patterns from the manufacturer, and the manufacturer needs a finished foundation to install the turbine. This is the crucial macro versus micro distinction that you must understand. PMI is macro. It's organizational. It decides the formality. Are we using software or a spreadsheet? ICAT is micro. It's from a project perspective. It doesn't decide the tools you use. It decides which relationships need the most attention from your interface manager. Think of it this way. PMI tells you that you need an interface manager. ICAT tells that interface manager which meetings they should attend on Tuesday morning. If ICAT shows that the interface between the IT systems team and the electrical team is extremely complex, the interface manager knows to focus their energy there to prevent a failure. But what makes an interface complex? Why is one pair of stakeholders riskier than another? To answer, what makes an interface difficult to manage? It's rarely just about the engineering. It's usually a combination of factors that we call interface influencing factors, or IIF. The ICAT tool looks at 4 main categories to determine the complexity score of a relationship. First, we have human and cultural factors. This is often overlooked in technical projects. If two teams have never worked together, lack of prior collaboration, or if they speak different primary languages, language proficiency, the risk of a misunderstanding skyrockets. Even different corporate cultures, for example, a fast-moving startup supplier working with a slow, bureaucratic government contractor, can create friction. Second are the logistical factors. In our globalized world, the design might be in London, the fabrication in South Korea, and the construction site in Australia. Geographical distance and massive time zone differences mean that a simple question can take 24 hours to get an answer. These delays add up and increase interface complexity. Third, we have the technical factors. This is the meat of the project. Does the interface involve a new technology that hasn't been used before? Are the two parties using different design codes or standards? If one contractor uses metric and the other uses imperial units, you have a high-risk technical interface. Finally, we consider environmental factors. These are the external conditions. Is the project being built in a hurricane zone? Is there political instability in the region that might affect the supply chain? The ICAT tool takes all these factors into account to generate a score. This matters because it moves us away from gut feelings about risk and toward a data-driven approach. Let's see how the ICAT process actually structures these factors into a usable result. The ICAT process is rigorous. It doesn't just ask, is this hard? It evaluates 15 key areas within each stakeholder interface. By answering a series of standardized questions about the influencing factors we just discussed, the tool generates a numerical value called the Interface Complexity Factor, or ICF score. This score ranges from 0 to 100. As you can see on the slider, a score in the green, low, means the interface is straightforward and likely doesn't need much oversight. But as the slider moves into the red, high, the interface becomes a high-priority item that requires active daily management. One of the most important things the ICAT tool does is help us distinguish between soft and hard interfaces. Hard interfaces are the physical connections. These are the pipes, wires, and structural beams that must physically fit together. These are usually easier to visualize, but can be very expensive to fix if they are wrong. Soft interfaces are often more dangerous because they are invisible. These involve the exchange of information, the logic of the project schedule, e.g., Party A must finish before Party B can start, and the coordination of planning. A failure in a soft interface, like a delayed permit or a missing datasheet, can stop a hard interface from ever being built. By using the ICAT, the project team can see exactly why an interface is in the red. Is it because of a physical connection, hard, or a communication breakdown, soft? This allows for targeted mitigation. We've covered a lot of ground, from the high-level PMI to the tactical ICAT. Now, let's shift our focus to how this information is typically tested, and the core concepts you need to remember for professional exams or certification. If you are preparing for a certification or a final assessment on interface management, this is the slide to study. There are several traps and key distinctions that frequently appear in exams. First, master the core definitions. If a question asks what an interface is, remember it's not just a physical joint, it's a connection point reflecting interdependencies. Also, memorize the 4 maturity elements: process, tools, people, and culture. You may be given a scenario where a project has great software but a blame-oriented culture, and you'll need to identify that the sustaining culture pillar is the weak point. The most common area of confusion is the PMI versus ICAT distinction. Remember this rule of thumb. If the question is about organizational strategy or selecting tools, like should we buy commercial software, the answer is PMI. If the question is about tactical prioritization or specific stakeholders, like which 2 contractors need the most supervision, the answer is ICAT. Keep an eye out for soft versus hard scenarios. If a question describes a conflict over a shared schedule or a language barrier, it's talking about a soft interface, and the tool to evaluate it is ICAT. Finally, there is a key lifecycle note. In the built environment, interface complexity is not static. It increases as the project progresses. In the beginning, you are just managing a few designers. By the middle of the project, you are managing hundreds of subcontractors, thousands of physical connections, and a mountain of data. This is why early intervention is so critical. We have now walked through the entire methodology. Let's wrap up with a summary of the most important takeaways that you can apply to your next project. In this session, we are moving beyond the basics to explore how we classify these connection points and the technical attributes that define them. Think of an interface as a handshake between two parts of a project. If that handshake is clumsy or misunderstood, the whole project feels the impact. We will be using comprehensive study notes designed to prepare you for high-level certification exams, ensuring you understand not just the what, but the how and the why behind professional interface management. This matters because in modern construction and engineering, we rarely work in silos. Everything is interconnected. By the end of this module, you'll have a professional vocabulary to describe these connections and a toolkit of forms and registers to manage them effectively. Let's begin by looking at the context of why standardization is no longer optional in our industry. Next, we will explore why the built environment demands such a high level of predictability. To solve this, we turn to the Construction Industry Institute, or CII. They provide the industry standard that brings discipline to these interactions. Today, we have three primary objectives. First, we will learn to classify interfaces by their specific type and category. Is it physical, functional, or perhaps organizational? Second, we will identify interface-specific attributes. Just like a person has attributes like height or eye color, an interface has attributes like geometry, material specs, and performance data. Finally, we'll look at the mechanisms for configuration management, which is the source of truth for all these moving parts. Understanding these classifications is the first step in moving from reactive firefighting to proactive management. When you can name a problem, you can solve it. For example, knowing the difference between a material attribute and a schedule link allows a project manager to assign the right expert to the right issue. Now that we have our objectives, let's look at the fundamental unit of this discipline, the interface point. But here is the key exam concept you must remember. An IP is a formal part of the project's scope. It is the exact moment or location where responsibility passes from one stakeholder to another. Imagine a relay race. The IP is the zone where the baton is handed over. If the baton is dropped, it happens at the IP. For a technical professional, this means that an interface isn't just a thing. It's a transition of liability and ownership. If you are the supplier of an interface, you are responsible for the delivery of information or hardware up to that point. If you are the receiver, you are responsible for what happens once it crosses that line. Understanding this transfer of responsibility is vital for avoiding legal disputes and schedule delays. Now that we've defined the point, let's look at how we classify the nature of the interface itself. A soft interface, however, is often more dangerous if ignored. This involves the exchange of information. It includes design criteria, clearance requirements, or utility needs. It also covers the human elements like regulatory compliance, language barriers, and even cultural differences between international teams. Here is an exam focus tip. Never assume soft means easy. In fact, soft interfaces are often the root cause of project failure because they are harder to track than a physical piece of steel. Next, we look at the boundary. An internal interface occurs within a single scope of work, perhaps between two departments in the same company. An external interface is much more complex, as it exists between two or more different scopes of work, usually involving different contractors or vendors. managing an external interface requires much stricter documentation because you are dealing with different contracts and legal entities. With these primary categories in mind, we can now look at specific classifications like physical, functional, and contractual. Second, we have functional interfaces. This is about operation. It's not just that the parts touch, but that they work together. For instance, if you have a control system from vendor A that needs to shut down a pump from vendor B, that is a functional interface. The requirement is the successful operation of the combined system. If the signal is sent, but the pump doesn't stop, the functional interface has failed, even if the wiring is physically correct. Finally, we have the contractual interface. This is a crucial concept for project managers. A contractual interface occurs whenever two stakeholders are linked by an agreement. Here is a rule of thumb. Every time you have two different work packages in a supply chain, you have created a contractual interface. These are defined during the planning stage and must be monitored through the entire project lifecycle. If contractor A is late, it triggers a contractual issue for contractor B who was waiting to start. These three, physical, functional, and contractual, form the backbone of technical interface management. But what about the people and the knowledge involved? Let's look at the organizational side next. Within these organizational ties, we manage three specific subtypes. First is the knowledge interface. This is the exchange of general information. It's the know-how that keeps the project moving. Second is the resource interface. This is very practical. It involves the shared use of equipment, labor, materials, and even physical space. If two different contractors both need to use the same heavy lift crane on Tuesday, you have a resource interface that needs managing. Finally, we have the social interface. This is often overlooked, but it is vital for project health. It captures human involvement and the social contracts that teams live by. It's about how we consult with one another, how we make decisions, and how we resolve disputes. A project with poor social interfaces will likely suffer from siloing, where teams refuse to help each other, leading to friction and delays. When you combine the organizational, knowledge, resource, and social aspects, you get a full picture of the soft side of interface management. Now, let's look at a critical attribute that separates easy interfaces from the difficult ones: time. Dynamic interfaces, however, are the ones that keep project managers awake at night. These arise because of activity interdependencies. They are strictly time-dependent. If an early-stage interface is neglected, say a foundation design that is delivered late, it doesn't just affect the foundation, it ripples forward. This delay affects the structural steel team, the piping team, and eventually the commissioning team. Here is your exam-focused tip. If you see a scenario where a problem causes a ripple effect or downstream delays due to early neglect, you are looking at a dynamic interface. Managing dynamic interfaces requires a deep understanding of the project schedule and the critical path. You have to identify which interfaces are the most time-sensitive, so you can prioritize them before they cause a bottleneck. So we've classified interfaces by nature, boundary, function, and time. Now let's look at what happens when we manage them poorly, and the mandatory attributes we must track to avoid failure. To manage this risk, we use a standardized list of mandatory interface attributes. You can think of this as a birth certificate for every interface. Every single interface must have a unique interface number for tracking, a revision number, so we know we are looking at the latest version, the date of the last revision, clear supplier and receiver details, who is giving and who is getting, a clear description of the activities and dependencies involved, formal signatures from both the supplier and receiver to prove agreement, and finally, closure signatures to confirm the work is finished. Without these 7 attributes, an interface is just a vague conversation. With them, it becomes a controlled technical document. This documentation process is what allows us to maintain an audit trail and ensure accountability. Now, how do we actually capture all this information in the real world? We use a specific tool called the Interface Agreement Form. Next, we have the Contact section. This is vital because it identifies the actual human beings responsible. It lists the technical contact and the company contact for both the supplier and the receiver. If there's a problem at 2 a.m., you need to know exactly whose phone to ring. The Details section is the meat of the document. This is where we describe the deliverable activities. It explicitly states what is being handed over. Is it a CAD file, a physical manifold, a set of test results? Whatever it is, it must be defined here, so there is no ambiguity. Finally, we have the sign-off section, which follows the life cycle of the interface. There are signatures for the initial agreement. Yes, we both agree this is the scope. For delivery, I have handed it over. And for closure, I have received it and it meets the requirements. This 3-stage sign-off is what provides the audit trail. The IAF is a powerful tool, but it only works if it's part of a larger system. Let's look at how we manage the configuration of all these forms across a whole project. This central system links 4 critical areas: the parties involved knowing who is responsible for what, the documentation, the actual IAFs and technical specs, the schedules, when is each interface due, the status updates, is it initiated, in progress, or closed. When you have transparency in these 4 areas, the project runs smoothly. But what happens when this system fails? The consequences are severe. You get inconsistent documentation, where the supplier thinks they are on revision 2, but the receiver is using revision 4. You end up with unknown status, where the project manager doesn't know if a critical connection is ready. Ultimately, this leads to the 2 things every engineer hates most: delays and rework. Rework is particularly painful because it means paying twice for the same job. By maintaining a central management system, you ensure that everyone is looking at the same data at the same time. Now let's look at the specific life cycle of an interface as it moves through this system. Stage 1 is initiated. This is when someone says, "Hey, we have a connection point here." It's assigned a number and put on the radar. No work has been done yet, but the interface is officially born. Stage 2 is released. This is a major milestone. It means the scope has been clearly defined, the supplier and receiver have been identified, and the formal IAF has been sent to them. The baton is now officially in play. Stage 3 is in progress. This is where the actual engineering or construction happens. The supplier is working to meet the requirements, and the receiver is preparing to receive the handoff. During this stage, status updates are critical to ensure that any delays are caught early. The final stage is closed out. This is the goal. It means the work has been delivered, the receiver has signed off on it, and the book is shut. The documentation is archived, and this specific risk is removed from the project. If you're a project controller, your job is to move as many items as possible from initiated to closed out as quickly and safely as possible. To see the big picture of all these life cycles, we use our second major tool, the Interface Data Register. A professional IDR contains several critical columns. We track the unique ID and title, obviously, but the real power comes from the date columns. We track the need date, when the project needs it done, versus the forecast date, when the team thinks they will actually finish. If the forecast date starts slipping past the need date, the IDR gives you an early warning signal. We also track the delivery date and the close date to ensure that nothing gets forgotten. Looking at the example on the slide, you can see interface XXYY001. It tells us who the parties are and shows that it is currently in progress. For anyone working in a project management office, PMO, the IDR is your primary tool for reporting. It allows you to say to stakeholders, we have 100 interfaces, 80 are closed, 15 are in progress, and 5 are delayed. This level of clarity is only possible if you maintain the register diligently. Now, as we move toward the end of this module, let's look at some critical distinctions you'll need for your exams and real-world scenario analysis. First, organizational versus social. An organizational interface is about the plumbing of the company, the hierarchy, the departments, and the formal parties. A social interface is about the people, the culture, how they talk to each other, and how they resolve fights. If a team is failing because they don't like each other, that's a social interface issue. Second, physical versus contractual. The physical interface is the pipe or the bolt. The contractual interface is the piece of paper that says contractor A must provide that pipe to contractor B. You can have a perfect physical design, but a failed contractual interface if the agreement doesn't specify who pays for the bolts. Third, static versus dynamic. Remember, static is a permanent relationship, like engineering talking to procurement. Dynamic is tied to the clock. If it's about a specific task causing a ripple effect, it's always dynamic. When you're analyzing a scenario, use these clues if the problem involves permits, laws, or language barriers. It's a soft interface. If two vendors are arguing about where a handoff happens, it's a contractual interface. If an early mistake is causing delays 6 months later, it's a dynamic interface. And if you need to know how to officially shut the book on a task, the answer is always final closure signatures on the IAF. Mastering these distinctions will make you a much more effective interface manager. Let's wrap everything up with a look at the full life cycle. Step 1 is to identify. You can't manage what you don't see. You must look at the project and classify every connection. Is it hard, soft, physical, or functional? Step 2 is to define. This is where you establish responsibility. You decide who is the supplier and who is the receiver. You make sure there are no gaps where responsibility is lost. Step 3 is to document. This is where you fill out your interface agreement form, IAF. You get the details down in writing so there is no he said, she said later in the project. Step 4 is to track. You take all those IAFs and put them into your master log, the Interface Data Register, IDR. This allows you to monitor dates and progress across the entire project. Finally, step 5 is to close. You don't just finish the work, you get the signatures. This officially removes the risk and completes the audit trail. The core message here is simple. Efficient management of these 5 steps is not just extra paperwork. It is essential for the successful completion of any complex project. When interfaces are managed, uncertainty is reduced and predictability goes up. For those interested in the future of the industry, look at the academic work by Dr. Chen on using BIM, Building Information Modeling, as a framework for interface management. It's a fascinating look at how digital twins are changing how we track connections. Finally, make sure you download and familiarize yourself with the IAF and IDR templates. Having a theoretical understanding is great, but being able to pick up a form and use it in the field is what makes you a professional. Thank you for your time and focus. You are now equipped with the vocabulary and the tools to manage complex interfaces and ensure project success. Have you ever wondered why some of the most technically sound projects still face massive delays and budget overruns during the commissioning phase? Often, the culprit isn't a lack of engineering talent, but a failure to manage the white spaces between different project teams. Welcome to this session on interface tools, processes, and capabilities. Today, we are diving deep into the strategic implementation of interface management, or IM, specifically looking at how we can turn chaotic project overlaps into streamlined, predictable workflows. First, we need to establish a foundation. We aren't just talking about talking to each other. We are discussing a rigorous methodology based on the Construction Industry Institute, or CII, framework. The CII is a world-class consortium of owners and contractors, and their framework provides a validated, industry-standard approach to managing the complex touchpoints of a project. This matters because, in a globalized market, your project isn't just happening in one office. It's happening across multiple disciplines, time zones, and organizations. Next, we will explore the specific strategies required for successful implementation. It's one thing to say you have an IM plan. It's another to have the organizational capabilities and specialized tools to execute it. We will look at how to move from basic spreadsheets to automated systems that capture data in real time. By the end of this module, you should be able to identify which tools fit your project's specific risk profile. Now, as we begin, keep in mind that IM is more than just a software solution. It's a mindset shift toward proactive coordination. Think of it as the glue that holds the different pieces of a mega project together. This sets the stage for our primary discussion, understanding why we need a formal case for IM and what challenges we are actually trying to solve. Imagine you are managing a $5 billion offshore oil rig construction. You have the hull being built in South Korea, the topsides in Norway, and the subsea equipment coming from Houston. What happens when the umbilical cable from Houston doesn't fit the connection point on the topside from Norway? This is the core challenge of mega projects. These projects involve hundreds of stakeholders and thousands of technical interfaces across diverse geographies. Without standardized tools, these connections become a breeding ground for waste, rework, and massive inefficiency. This brings us to our primary learning objectives for this session. First, we are here to design and apply effective interface management practices. We won't be guessing. We will be using the proven CII framework to ensure our methods are grounded in global best practices. This matters because a standardized approach allows different companies to speak the same language when a conflict arises, rather than wasting weeks in finger-pointing sessions. Secondly, we will identify the specific industry-leading tools that make IM possible. We will define and explore the Master Interface Plan, or MIP, which acts as our strategic playbook, and the Interface Control Document, or ICD, which serves as our physical blueprint for connection points. Understanding these tools is essential for any project manager or interface coordinator who wants to maintain control over a shifting scope. Finally, our goal is optimization. We want to use technology to improve efficiencies at every maturity level, whether you are working on a small expansion or a massive greenfield site. This isn't just about high-end software. It's about choosing the right level of technology for the risk at hand. To get there, we must first understand the core tools of the trade, starting with how we plan and register these critical points of contact. If you were coaching a sports team, you wouldn't just tell the players to go out and play. You would have a playbook that defines every position and every move. In the world of interface management, that playbook is the Master Interface Plan, or MIP. The MIP is a detailed document that describes exactly how the project will manage interface points, known as IPs, and interface agreements, or IAs. This is where we define our management procedures, our internal and external workflows, and most importantly, the specific responsibilities of every stakeholder involved. Now, while the MIP provides the high-level strategy, we also need a tactical tool for the day-to-day work. This is where the IM spreadsheets, or registers, come into play. Think of the MIP as the how-to guide, and the register as the to-do list. The register is the basic tool used for tracking every single IP. It records the status of interface agreements, which are the formal communications used to exchange deliverables between two parties. If Team A needs a pipe diameter from Team B to finish their design, that request and its deadline are tracked right here in the registry. It's important to note the maturity context here. Using spreadsheets for IM typically aligns with stage 1 of the IM maturity model. While it is a significant step up from just sending emails, it is still a manual process. This matters because manual registers require constant human intervention to stay updated, which can be a risk in fast-moving environments. However, for many smaller projects, this tactical focus on the registry of items is exactly what is needed to maintain clarity. So, we have our strategy in the MIP and our tracking in the register. but as a project grows in complexity. How do we ensure that the technical details don't get lost in the shuffle? This leads us to the next category of tools, those focused on physical control and high-level automation. Have you ever seen a set of blueprints where a mechanical pipe seems to pass right through an electrical cable tray? That is a classic interface failure. To prevent this, we use the Interface Control Document, or ICD. If the MIP we discussed earlier is the playbook, the ICD is the physical representation. It is the drawing or data sheet that shows exactly where two systems meet. Its function is to act as the single source of truth for the physical characteristics of an interface point. More importantly, the ICD captures approved change requests. If a contractor wants to move a flange 6 inches to the left, that change must be reflected in the ICD so everyone else can adjust their work accordingly. Next, let's talk about the engine that drives modern projects, interface management software. As projects move from hundreds of interfaces to tens of thousands, spreadsheets simply break down. The purpose of dedicated IM software is to automate workflows, improve efficiency, and perhaps most importantly, eliminate waste. When you use a system like Interface Connect, Aconex, or Asai, you aren't just storing data. You are creating a digital environment where deadlines are tracked automatically and stakeholders are notified the moment a deliverable is late. This shift to software is a fundamental element for increasing your IM maturity. It moves the project away from reactive management, where you find out about a problem because someone started screaming, and toward proactive management, where the system flags risks before they become physical clashes. This matters because the cost of fixing a mistake in a software model is negligible compared to the cost of cutting and re-welding steel in the field. By integrating these tools, we move closer to a fully optimized project environment. But how do we measure where we are on that journey? This brings us to a critical concept in the CII framework, the IM maturity model, which helps us track our progression from informal to formal implementation. Think about how your own project team communicates. Is it a chaotic flood of emails, or is everything tracked in a centralized live system? This difference is exactly what the IM maturity model measures. We start at stage 0, the traditional stage. Here, IM is informal. You'll find information buried in emails, local file folders, and static lists that are out of date the moment they are saved. This is a high-risk environment because there is no single version of the truth. As we move to stage 1, we see manual tracking. This is where those IM spreadsheets we talked about come in. It's better than stage 0 because there is a central register, but it still relies heavily on manual updates. Moving up to stage 2, we introduce fundamental automation. Here we start using tools with basic workflows, perhaps a document management system that can send a notification when a file is uploaded. The real leap happens at stage 3, the standalone system. At this level, the project is using a dedicated IM software platform. It is fully automated with real-time status tracking. You can see exactly which interface agreements are open, pending, or closed at any second. But the gold standard is stage 4, fully integrated. At this peak level, your IM system isn't just a silo. It is sharing data directly with your project schedule, your change management system, and your risk management register. If an interface delivery is delayed by 2 weeks, stage 4 maturity means the project schedule automatically updates to show the impact on the critical path. This progression matters because as maturity increases, efficiency climbs and risk drops. However, not every project needs to be at stage 4. A small office renovation doesn't need a fully integrated IM suite. So how do we decide which level of maturity is right for our specific project? To answer that, we need a strategic decision-making tool called the PMI matrix. One of the biggest mistakes a company can make is over-managing a simple project or under-managing a complex one. How do you find the Goldilocks zone of interface management? The answer lies in the PMI matrix, which stands for Project Interface Risk Impact. This is a high-level strategic tool used to determine exactly how much IM structure your project actually requires. The PMI matrix works by looking at three core inputs. First is project complexity. How many moving parts, disciplines, and contractors are we dealing with? Second is the risk level. What are the chances of something going wrong? And third is business impact. If this project fails or is delayed, what does it do to the company's bottom line? We feed these three factors into the PMI matrix to get a clear picture of what we need to succeed. The output of this matrix tells us three things. 1. What kind of qualified people do we need? Do we need a dedicated interface manager, or can a project engineer handle it part-time? 2. What enabling tools and systems are required? Do we need a Stage 4 integrated software, or is a Stage 1 spreadsheet enough? And 3. What business processes must be in place? The ultimate goal here is alignment. By matching your project to its appropriate cell in the PMI matrix, you establish a realistic and effective end state for your IM program. This prevents you from wasting money on expensive software for simple tasks, while ensuring you don't walk into a mega project with nothing but a notepad and a prayer. Now let's take a closer look at the actual structure of this matrix to see how these classifications work in practice. On the horizontal x-axis, we measure project or business impact, from low to high. On the vertical y-axis, we measure project interface complexity and risk, again, from low to high. Where these two meet determines your IM strategy. First, look at the green zone in the bottom left. This is informal IM. We use this when both complexity and business impact are low. In this scenario, you likely don't need a specialized interface expert. A basic manager can handle the coordination using simple spreadsheets. It's cost-effective and sufficient for the task at hand. Next, as we move into the yellow now that we understand the theory behind the PMI matrix, let's look at the actual grid. This is the visual guide that tells you which tier of interface management you should be aiming for. Zone. We transition to formal IM. This is the middle ground for projects with medium complexity or impact. Here the stakes are high enough that you need a dedicated manager, someone whose primary job is to watch the interfaces. You also step up your technology, moving into commercial IM software to ensure that no data is lost and that workflows are followed strictly. Finally, look at the red zone in the top right. This is where we implement most formal IM. This is reserved for the high-risk, high-impact giants. In this zone, standard software isn't enough. You need integrated systems. This means your interface data is tied directly into your project schedule and risk registers. If a milestone is missed, the whole project team knows instantly. This matters because it provides a clear roadmap for scaling your management efforts. A one-size-fits-all approach to IM usually fits no one. By using this matrix, you can justify the budget for a dedicated manager or a new software suite by pointing to the specific cell your project occupies. To make this even clearer, let's walk through two real-world scenarios. To really understand how to apply the PMI matrix, let's look at two very different projects. First, Case A, a retail expansion. Imagine a company building its 30th franchise store. They are using a sole source contractor they've worked with for years, and resources are plentiful. Because the company has done this 29 times before, the complexity and risk are very low. If the store opens a week late, the business impact is minimal in the grand scheme of things. Therefore, this project lands in the green zone. Informal IM using spreadsheets is perfectly sufficient. Now compare that to Case B, a fertilizer plant expansion in a remote location like Kenya. This project involves brand new technology, strict environmental permits, and over 400 complex tie-in points with existing equipment. The location is remote, making logistics a nightmare. This is a high-complexity, high-risk project with a high business impact. If this plant doesn't come online on time, the company loses millions in exported product. This lands squarely in the red zone. It requires the most formal IM, including integrated software and a rigorous control team. However, there is a very important pro tip to remember here. Business impact can sometimes override low complexity. Let's say you are just replacing a single valve on a major cross-country pipeline. Technically, it's a simple job, low complexity. But if that valve fails or the installation is delayed, the entire pipeline shuts down, stopping all product export. That is a high business impact. In this case, you would move from informal to formal IM just because the cost of failure is so high. While the PMI matrix gives us the big picture of the project, sometimes the real trouble lies in the relationship between two specific groups. Maybe the structural team is in London and the fabrication yard is in China. They speak different languages, work in different time zones, and have different cultural approaches to deadlines. This is where we use the ICAT, the Interface Complexity Assessment Tool. The ICAT is a tactical, lower-level tool designed to help us prioritize interfaces that require active management between specific pairs of stakeholders, what we call Stakeholder A and Stakeholder B. It's important to understand the differentiation here. PMI tells you how to manage the entire project, while ICAT tells you how to manage a specific relationship within that project. How does it work? The ICAT evaluates 15 different interface influencing factors, or IIFs. These are the hidden risks that often go ignored until they cause a disaster. We look at factors like, do these two teams speak the same language? Is there a significant geographical distance or time zone gap? Have these two companies worked together before? Are their technical standards and software compatible? This matters because not every interface pair is created equal. You might have 10 contractors, but only one pair that is high risk due to these influencing factors. By using the ICAT, you can focus your limited management resources where they are needed most. It allows you to say, we need to keep a very close eye on the interaction between the London and China teams, even if the rest of the project is running smoothly. Now let's look at how we actually score these factors to get a usable result. To make the ICAT more than just a gut feeling, we use a standardized scoring process. It's a simple 3-step method. First, we take those 15 interface influencing factors we just discussed and rate each one on a scale of 0 to 2. A 0 means no risk. For example, both teams are in the same office. A 2 means high risk. For example, the teams are on opposite sides of the world with no common language. Second, we apply weightings. Not every factor is equally important. In some projects, a time zone difference might be a huge deal, while in others, it's just a minor inconvenience. We use default or calibrated weightings to reflect the project's specific reality. Finally, we calculate the interface complexity factor, or ICF. This gives us a final score ranging from 0 to 2. This score maps to 4 distinct levels of complexity. Level 1 interfaces are simple and straightforward. As the score increases, we move through level 2 and 3 until we hit level 4, complex interfaces. This matters because it gives you a thermometer for your interface health. If an interface pair hits level 4, it's a flashing red light. The rule is simple. The higher the complexity level, the more formal the IM strategy must be for that specific interface. You might decide that level 4 interfaces require weekly face-to-face video calls and a dedicated coordinator, while level 1 interfaces can be handled through standard email updates. By quantifying the complexity, you move away from subjective opinions and toward data-driven management. Now that we have our strategy and our tools, it's time to look at the actual workflow we use to handle these interfaces day to day. Success in interface management isn't just about having the right tools. It's about having a repeatable, systematic workflow. This is what we call the IMS framework, the Interface Management System. Think of this as a 6-step cycle that every single interface point must go through from the moment it is discovered until the day it is physically completed and signed off. The ultimate goal of this entire framework is alignment. We want every stakeholder to agree on 3 critical things. The characteristics of the interface, what is it? The responsibilities, who owns it? And the due dates, when is it needed? If you have alignment on these 3 points, 90% of your interface problems disappear. The journey starts with step 1, identification. This is where we scour our documents to find where things meet. Once identified, we move to step 2, documentation, where we define the scope and who is involved. Step 3 is transferring or issuing, where the responsibility is formally handed over to the contractors. Step 4 is communication, the live exchange of information through interface agreements. But we don't just stop there. Step 5 is monitoring and control. We need a dashboard to see if we are on track. Finally, step 6 is closing. We need a formal handshake to confirm that the work is done and correct. This matters because a project that doesn't close its interfaces effectively will face massive problems during the commissioning phase. Over the next few slides, we are going to break these 6 steps down into pairs to see exactly how they function in a professional environment. The first 2 steps of our framework are all about setting the foundation. Step 1 is identification. You might think we identify everything at the start, but that's rarely the case. While we look at design documents, the work breakdown structure, WBS, contracts, and specifications, identification is actually an ongoing process. As a project evolves from front-end engineering to detailed design, new interfaces will pop up. The benefit of early and continuous identification is simple. It reduces risk. The sooner you know that Team A needs data from Team B, the more time you have to manage that interaction. Once we've identified an interface, we move to step 2, documentation. This is where we get specific. We define the nature of the interface. Is it physical, functional, or organizational? We define the scope. What exactly is being exchanged? And we define the categories. Does this belong to the mechanical, electrical, or civil discipline? The most critical tool we use during this documentation phase is the RACI matrix. For those unfamiliar, RACI stands for responsible, accountable, consulted, and informed. We use this to eliminate the "I thought you were doing that" excuse. We assign one person who is accountable for the interface, the owner, and others who are responsible for doing the actual work. This matters because without a RACI matrix, interfaces often fall through the cracks. If 2 people think they are both consulted, but neither thinks they are responsible, the work never gets done. By defining and aligning early, we create a clear path for the next phase, handing these interfaces off to the people who will actually build them. Now we move from the planning phase into the action phase. Step 3 is transferring or issuing. The primary trigger for this step is the contract award. Once a contractor is signed on, we formally hand over the interface points that fall within their scope of work. But this isn't just a one-way street. The contractor must perform a validation check. They review the IPs we've given them for adequacy and accuracy. This matters because if a contractor accepts an interface that is poorly defined, they are inheriting a risk that could lead to a future change order or claim. Once the interfaces are successfully transferred, we enter step 4, interface communication. This is the heartbeat of the interface management system. The primary mechanism here is the interface agreement, or IA. Think of an IA as a formal mini-contract between 2 stakeholders. If the electrical team needs the weight of a motor from the mechanical team, they issue an IA. The process is rigorous. Both parties must approve the accuracy of the request and the proposed delivery date. If a contractor discovers a new interface during this communication phase, which happens often, they can't just add it to the list. It must be recognized and approved by the interface coordinator to ensure it doesn't conflict with the overall master interface plan. This step is where most projects fail. If communication is handled via informal phone calls or emails, there is no record of what was promised. By using formal IAs, you create a clear paper trail that ensures everyone is held to their commitments. But how do we keep track of all these moving parts? That's where monitoring and closure come in. As a project reaches its peak, you might have thousands of active interface agreements. You can't track that in your head. Step 5 is monitoring and control. To do this effectively, we use an EPPMS, an electronic product and process management system. This is our mission control. It allows the interface coordinator to assess performance in real time using on-screen indicators. Think of it as a traffic light system. Green means we're on track, yellow means a deadline is approaching, and red means an agreement is overdue. The system also handles automated workflow notifications. You don't have to manually check if Team B sent their data. The system will ping you the moment it happens. This matters because it allows the management team to focus only on the exceptions, the problems that actually need human intervention, rather than wasting time on things that are running smoothly. Finally, we reach the end of the journey. Step 6, interface closing. This is the most overlooked step in the process, but it is vital for project success. A deliverable being sent is not the same as it being closed. For an interface to be closed, the accountable party must approve the accuracy and adequacy of what was delivered. During this process, the consulted party has one last chance to accept the work or raise an objection. Only once both sides are satisfied is the interface formally marked as closed in the EPPMS workflow. This final handshake ensures that when you get to the construction site, everything actually fits. If you skip this, you're just pushing your problems downstream to the most expensive phase of the project. As we wrap up our deep dive, let's focus on the high-yield points that are essential for both your professional practice and any potential certification exams. These are the most common areas where professionals get tripped up, so pay close attention. First, clarify the difference between the MIP and the ICD. Remember, MIP is your plan. It's about procedures and how you manage. The ICD is the physical reality. It's the drawing or technical data sheet. Next, keep the maturity levels straight. Stage 0 is the chaos of email. Stage 4 is the nirvana of a fully integrated system where schedule and risk data are shared. When it comes to the PMI matrix, remember the scenario rule. While we usually look for both high risk and high impact to move to the red zone, high business impact alone can be enough to mandate a formal IM strategy. If a mistake will cost the company $10 million a day, you don't care if the technical work is simple. You manage it formally. Regarding the ICAT tool, remember it's for stakeholder pairs. It uses 15 influencing factors, IIFs, to generate a score between 0 and 2. A score of 0 is a simple, low-risk relationship. A score of 2 is a complex, high-risk one. Also, memorize the order of the 6-step IMS framework: identification, then documentation, transfer, communication, monitoring, and finally, closing. Lastly, note that the RACI matrix is a tool used specifically during Step 2, documentation. This is where you define who is accountable before any work begins. These points form the backbone of a professional interface management strategy. Let's bring it all together with a final summary. Have you ever been on a project where nobody seemed to know who had the final say on a critical budget change? Or perhaps a project where decisions were made only to be reversed a week later because the wrong person was consulted? These are the classic symptoms of a project lacking a robust governance framework. Today, we are diving deep into project governance and decision authority, a cornerstone of the PMI-CP construction professional curriculum. This isn't just about red tape. It is about creating the structural integrity of your project's management. In the world of the built environment, where the scale is massive and the stakes are even higher, governance acts as the rules of the game. It defines how we make decisions, how we manage risk, and how we ensure that every dollar spent aligns with the ultimate goals of the organization. Throughout this module, we will explore why governance is the secret weapon of high-performing project managers. We will move beyond the theory and look at how clear authority levels can actually speed up your project rather than slow it down. Let's begin by understanding the professional context and the rigorous standards that underpin this certification. How do we know that what we are learning is actually what happens on a real construction site? It is a fair question. The content for this certification isn't just academic theory. It is the result of a global role delineation study and a job task analysis. This means that thousands of professionals across the globe were consulted to define what a construction project manager actually does day to day. By aligning with the standards for educational and psychological testing, we ensure that the examination is a valid and fair measurement of your professional skills. It is important to note that this material was developed by a panel of expert practitioners specifically from the built environment. While the PMI-CP Guide, 7th edition, provides a fantastic general framework for project management, what we are discussing here is specialized. We are focusing on the unique challenges of construction, from safety and procurement to complex stakeholder webs. This ensures that when you apply these governance principles, they are tailored for the real-world competence required in high-stakes construction settings. Understanding this foundation is key before we look at how the exam itself is weighted across different domains. If you were to look at the Examination Content Outline, or ECO, you might notice something surprising. Project governance only accounts for 5% of the total questions on the exam. Meanwhile, contracts management sits at 50% and stakeholder engagement at 30%. You might be tempted to think governance is a minor topic, but that would be a significant professional mistake. Here is the key insight. While it is only 5% of the questions, governance is the invisible hand that directly influences the predictability of your costs and schedules across all other domains. How do we know that what we are learning is actually what happens on a real construction site? It is a fair question. The content for this certification isn't just academic theory. It is the result of a global role delineation study and a job task analysis. This means that thousands of professionals across the globe were consulted to define what a construction project manager actually does day to day. By aligning with the standards for educational and psychological testing, we ensure that the examination is a valid and fair measurement of your professional skills. It is important to note that this material was developed by a panel of expert practitioners specifically from the built environment. While the PMI-CP Guide, 7th edition, provides a fantastic general framework for project management, what we are discussing here is specialized. We are focusing on the unique challenges of construction, from safety and procurement to complex stakeholder webs. This ensures that when you apply these governance principles, they are tailored for the real-world competence required in high-stakes construction settings. Understanding this foundation is key before we look at how the exam itself is weighted across different domains. If you were to look at the Examination Content Outline, or ECO, you might notice something surprising. Project governance only accounts for 5% of the total questions on the exam. Meanwhile, contracts management sits at 50% and stakeholder engagement at 30%. You might be tempted to think governance is a minor topic, but that would be a significant professional mistake. Here is the key insight. While it is only 5% of the questions, governance is the invisible hand that directly influences the predictability of your costs and schedules across all other domains. Think of it this way. You cannot have effective contracts management if you don't have a governance framework telling you who has the authority to sign those contracts. You cannot engage stakeholders effectively if your governance hasn't defined their roles and influence. Governance provides the scaffolding that allows the other 95% of the project work to stand firm. In this module, we will treat that 5% with the weight it deserves, knowing it is the foundation for everything else. Now that we see where it fits in the curriculum, let's define exactly what we mean when we say project governance. What does governance actually mean in a construction trailer or a corporate boardroom? Formally, it is the process of decision-making within a structured framework. Its goal is to ensure that your project objectives are in perfect harmony with the processes you use and the resources you consume. As O.E. Williamson famously put it, governance is an effort to craft order. By doing so, we mitigate the inevitable conflicts that arise on a job site and ensure everyone achieves mutual gains. The industry reality, however, is quite sobering. According to PwC, staying under budget is the exception, not the rule in capital projects. Even more startling is data from the Construction Industry Institute, which shows that only 5.4% of industrial projects meet what we call best-in-class predictability. Why is this? Often it's because the order Williamson spoke of is missing. When there is no clear framework, decisions are delayed and costs spiral. By establishing a firm governance structure, we aren't just following rules, we are actively fighting against these industry statistics to ensure our project is one of the few that succeeds. Next, we'll look at the specific, tangible benefits that a strong structure brings to your daily work. Why go through the effort of setting up a complex governance structure? It comes down to 4 major pillars of project health. First, it establishes a single point of accountability. In construction, everyone is responsible usually means no one is responsible. Governance creates one source of truth, where communication flows from the right source to the right person at the right time. This eliminates the he said, she said drama that can stall a project for weeks. Second, it transforms your risk and issue management. Instead of reacting to fires, you are proactively identifying risks before they become project-stopping issues. Third, it defines roles and relationships. When everyone knows exactly what is required of them and when it is due, established right at the start, you eliminate the friction of role ambiguity. Finally, it fosters transparent communication. Through the timely distribution of management information and key performance indicators, or KPIs, every stakeholder has the data they need to make informed decisions. These benefits don't happen by accident. They are the result of adhering to core governance principles, which we will examine next. Let's get into the first 2 foundational principles of governance. Principle number 1 is the establishment of clear accountability. This starts with the project board, which is responsible for identifying the high-level outcomes and key accountabilities. Underneath them, the project manager must have clearly defined authority. This includes knowing exactly what powers are delegated to them, and just as importantly, knowing the specific escalation paths when a problem exceeds their authority. We also use decision bodies. These are expert groups empowered to provide technical or financial support for complex choices. Principle number 2 is the identification of key stakeholders. This must happen at the very beginning of the project. However, there is a major trap here: the too many cooks in the kitchen syndrome. If you involve too many stakeholders in the actual decision-making process, you will suffer from decision paralysis, where nothing gets approved because everyone wants a say. Your job is to find the balance, identifying who needs to be involved while defining clear roles and responsibilities to keep the project moving. As we move forward, we'll see how systems and delivery focus round out these principles. Moving on to principles 3, 4, and 5, we start looking at the machinery of governance. Principle 3 focuses on systems and processes. In modern construction, this means implementing a Project Management Information System, or PMIS. This system handles your finances, reporting, and overall information management, ensuring that data is consistent and accessible. Without a solid PMIS, you are essentially flying blind, relying on outdated spreadsheets. Principle 4 is monitoring and reporting. You need regular reporting schedules established from day one. This isn't just about checking boxes. It is vital for catching early warning signs of risk, allowing you to mitigate them proactively. Finally, Principle 5 is perhaps the most important for project managers to remember: a focus on delivery. Governance does not exist to create paperwork or hinder progress. It exists to support delivery. A good governance framework must be agile enough to allow the project team to respond to changes without being strangled by bureaucracy. It should be the wind in your sails, not the anchor holding you back. With these principles in mind, let's look at the best practices for structuring and documenting your governance. How do we put these principles into practice? It starts with 2 critical artifacts and a process. First, roles and responsibilities must be documented and agreed upon within the project charter. Think of the project charter as your North Star. It is the primary document that defines why the project exists, the business case behind it, the high-level goals, the timeline, and the scope. If it isn't in the charter, it effectively doesn't exist in the eyes of governance. The second best practice is the use of stage gates. These are specific decision points at the end of project phases where executives must make a go or no-go decision before the project can proceed to the next stage. Stage gates prevent project creep, where a failing project continues to consume resources simply because no one stopped to check if it still made sense to continue. By combining a clear charter with rigorous stage gates, you create a project environment that is both disciplined and transparent. But documentation is only half the battle. Next, we'll look at how oversight and risk management keep the project on track. Effective oversight requires clear leadership and a commitment to rigor. This brings us to the single point of contact. This should be a person of appropriate seniority who has the teeth to enforce governance adherence. If someone tries to bypass the rules, this individual steps in. Parallel to this is the Project Governance Board. This board must meet regularly, following a strict discipline of agendas, minutes, and tracked actions. Furthermore, they should obtain independent assurance, such as external audits, to ensure the project's rigor isn't just a surface-level appearance. We also have to change how we think about risk management. In construction, we are often very good at identifying technical risks, like ground conditions or structural integrity, but we sometimes neglect commercial risks. Governance dictates that commercial risks, such as market fluctuations or subcontractor insolvency, must be treated with the same weight as technical ones. This requires resourcing your risk management team adequately. It's not a part-time job, it's a core function of the project's survival. Now, let's pull all these pieces together and look at the 8 specific components that make up a full governance structure. To build a world-class governance system, you need to address these 8 components. Think of this as your project's circular economy of management. It starts with the overall governance framework, the big picture of how decisions happen. Then we move into the specifics, defining roles and responsibilities, and ensuring stakeholder engagement is active and meaningful. We then set the rhythm of the project through meetings and forums. The bottom half of our circle focuses on the data, communication and reporting, followed by risk and issue management to handle the what-ifs. Finally, we close the loop with assurance, checking that we are doing what we said we'd do, and project management control, which is our ability to steer the ship day to day. Over the next several slides, we are going to break these down one by one, starting with the framework itself and how decision authority is actually distributed. The first component, the governance framework, is all about hierarchy and delegation. At the top, we have the project board, which holds the ultimate decision authority. But a high-level board shouldn't be deciding what type of valve to use in a mechanical room. That is an inefficient use of their time. Instead, the framework delegates specific types of decisions to specialized sub-boards. For example, a finance board might handle all complex budgeting issues. A design authority, made up of engineers and technical experts, would handle technical changes. A government or regulatory group might manage advisory and compliance issues. The goal here is efficiency. We want decisions made at the lowest level possible that still has the required expertise and authority. This keeps the project board focused on strategy and prevents them from becoming a bottleneck for technical progress. Once the framework is set, we need to clarify exactly who does what within it. To remove ambiguity, every project manager should be an expert in the RACI matrix. RACI is an acronym that defines 4 levels of involvement. R stands for responsible. This is the person actually doing the task. AE is for accountable. This is the one neck to wring, the person who signs off and owns the final result. Crucially, you can only have one person accountable for any given task. C stands for consulted. These people provide vital input before a decision is made. Finally, I is for informed, those who need to be kept in the loop after a decision is made, but don't necessarily provide input. As a project manager, you must set this matrix out at the very beginning. If you wait until a crisis hits to decide who was consulted versus who was accountable, it's already too late. A clear, racy matrix is the best defense against internal conflict. With roles defined, we can now look at how we categorize and engage the people outside and inside our immediate team. Stakeholders are broadly categorized into two groups: internal and external. Internal stakeholders are those within your organization, your management, your direct project team, and the resource managers who provide your labor and equipment. External stakeholders are the outside world, your customers, government regulators, contractors, and suppliers. Governance requires a strategy for both. Stakeholders are broadly categorized into two groups: internal and external. Internal stakeholders are those within your organization, your management, your direct project team, and the resource managers who provide your labor and equipment. External stakeholders are the outside world, your customers, government regulators, contractors, and suppliers. Governance requires a strategy for both. When it comes to the governance board itself, best practice suggests a diverse composition. You obviously need a meeting chair to lead, but you also need experts in design, finance, and asset management. Often overlooked but critical are business change managers, people who understand how the finished project will change the way the client actually operates. Including these varied perspectives on the board ensures that the project isn't just built correctly, but that it actually delivers the value the stakeholders expect. Of course, all these people need a place to talk, which brings us to meetings and forums. Stakeholders are broadly categorized into two groups: internal and external. Internal stakeholders are those within your organization, your management, your direct project team, and the resource managers who provide your labor and equipment. External stakeholders are the outside world, your customers, government regulators, contractors, and suppliers. Governance requires a strategy for both. When it comes to the governance board itself, best practice suggests a diverse composition. You obviously need a meeting chair to lead, but you also need experts in design, finance, and asset management. Often overlooked but critical are business change managers, people who understand how the finished project will change the way the client actually operates. Including these varied perspectives on the board ensures that the project isn't just built correctly, but that it actually delivers the value the stakeholders expect. Of course, all these people need a place to talk, which brings us to meetings and forums. Meetings are the heartbeat of governance, but they can also be its downfall. You are looking for a Goldilocks balance. If you have too many meetings, you fall into paralysis, where everyone is talking and no one is working. If you have too few, you face a breakdown in communication and alignment. You should have a structured hierarchy of meetings, from high-level quarterly boards and steering committees down to daily or weekly project team meetings. Every one of these meetings must have a terms of reference, or TOR. The TOR is the constitution of that specific meeting. It defines the meeting's purpose. Does it have decision authority or veto power? It lists the roles, such as the chair, expert members, and the secretary who records the actions. Finally, it sets the operations. How often do we meet? What is the standing agenda? And what is the quorum, the minimum number of members required to make a binding decision? A meeting without a TOR is just a conversation. A meeting with a TOR is a governance tool. Next, we'll look at how we track the results of these efforts through reporting and control. The final four components of our governance circle are what give the system its teeth. Component 5 is communication and reporting. We use standardized KPIs and management information to ensure everyone is looking at the same data. This prevents the dangerous situation where the PM thinks the project is green, while the finance board sees it as red. Component 6 is risk management, specifically focused on detecting early warnings. Are we seeing scope creep? Are designs coming in late? Is there a procurement delay? Governance ensures these are flagged before they become catastrophes. Component 7 is assurance. We typically use a 3 lines of defense model involving internal management, corporate oversight, and independent external audits. This verification provides the transparency that investors and executives demand. Finally, Component 8 is project management control. This is where we use our PMIS data to forecast future deviations. If the data shows we are slipping, governance gives us the authority to reallocate resources immediately to get back on track. This proactive control is what separates elite project managers from the rest. Now, let's wrap up with what you need to know for your examination. When you sit for the exam, there are several key governance markers you should look for. First, remember that the project charter is your primary artifact. It's the foundation of everything. The RACI matrix is your go-to tool for role definition, and stage gates are the critical checkpoints for executive decisions. If a question asks how a board's power is defined, the answer is the terms of reference, or TOR. And never forget that true governance must include independent assurance through audits. Pay close attention to the scenario tips provided here. If you encounter a question where a project is stuck and no decisions are being made, look for too many stakeholders as the likely culprit. If a senior stakeholder tries to go around your back and give orders directly to your team or a contractor, your professional response should be to refer them back to the established governance framework. This isn't being difficult, it's being a disciplined manager. Let's summarize the major takeaways from this module. As we conclude, remember that project governance is ultimately about alignment. It ensures that our massive consumption of resources, money, labor, and materials actually results in the objectives we set out to achieve. To do this, you must have clear accountability, a functional RACI matrix, and reporting that doesn't hide the truth. One of the most important mindset shifts for many technical professionals is to treat commercial risks with the same weight as technical ones. A perfectly engineered bridge is a failure if the company building it goes bankrupt halfway through. Finally, keep this statistic in mind. 33% of mega projects fail due to communication issues. Robust governance is the direct solution to that problem. It creates the channels, the language, and the authority for clear communication. Now, I want to open the floor to your questions and see how we can apply these principles to your specific projects. We've covered a lot of ground today, from the foundational principles of accountability to the technical setup of a RACI matrix and the strategic importance of stage gates. Now it's your turn. What challenges are you currently facing with decision authority on your projects? Are you struggling with decision paralysis, or perhaps a lack of clear escalation paths? Welcome to this critical module on the PMI Construction Professional, PMI-CP, TM, certification journey. Have you ever wondered why some massive construction projects, despite having the best engineers and unlimited budgets, still seem to spiral into chaos? Often the missing link isn't a lack of technical skill, but a lack of a stable skeleton to hold the project together. That skeleton is what we call project governance. In this section, titled Part 5, Establishing Appropriate Governance Structures, we dive deep into how professional judgment and ethics form the bedrock of successful project oversight. This course is designed specifically to prepare you for the PMI-CP TM credential, a certification that speaks directly to the complexities of the built environment. Governance is more than just a set of rules. It's about creating a framework where decisions are made transparently, ethically, and efficiently. As a construction professional, your ability to exercise sound judgment within these structures is what will set your projects apart from those that struggle with conflict and mismanagement. Throughout this session, we will explore how to build these structures from the ground up. We'll look at how to define authority, how to ensure accountability, and how to align every single resource on site with the ultimate objectives of the client. This is where the big picture meets the daily grind of the construction site. By the end of this module, you will understand not just the what of governance, but the how of implementing it in real-world mega projects. Let's begin by looking at the foundation of this certification and why the knowledge we are about to cover is so vital for today's industry. Before we get into the technicalities of governance, it's important to understand where this information comes from. Why should you trust these specific principles? The PMI-CP TM exam isn't just a collection of theoretical ideas. It is built upon a rigorous foundation known as a role delineation study and a job task analysis. What this means for you, the learner, is that every task we discuss has been statistically verified as being critical to the success of a construction project. We aren't just looking at what might happen. We are measuring tasks based on their frequency in the field and how vital they are to the project's survival. A key differentiator you need to keep in mind for your exam preparation is that this content is built environment specific. While many of you may be familiar with the PMI-CP R Guide, 7th edition, it is a crucial note that the PMI-CP TM content differs from it. This certification is not strictly bound by the PMI-CP R. Instead, it is driven by the collective experience of global built environment practitioners. This is a by pros for pros approach. Expert panels from across the globe have validated these materials to ensure they reflect the messy, complex, and high-stakes reality of a modern construction site. This matters because, in construction, the general management rules often need to be adapted to handle long lead times, massive physical risks, and complex subcontracting layers. When you sit for the exam, remember that the questions were written and reviewed by qualified construction professionals who have stood where you stand. They are looking for your ability to apply practical experience within the examination content outline. Now that we understand the weight behind this certification, let's look at how the exam itself is weighted across different domains. When you look at the breakdown of the PMI-CP TM examination content outline, you might be tempted to overlook our current topic. After all, project governance represents only 5% of the total exam score. Compare that to the massive 50% dedicated to contracts management, or the 30% for stakeholder engagement, and it looks like a small slice of the pie. However, there is a vital key insight you must internalize. While governance is only 5% of your score, it is the structural framework that enables the other 95% of project delivery. Think of it this way. If contracts management is the engine and stakeholder engagement is the fuel, project governance is the chassis of the vehicle. Without a solid chassis, the engine has nowhere to sit, and the fuel has nowhere to go. Governance provides the rules of engagement for how contracts are signed, how stakeholders are managed, and how the scope is defined. Without that 5%, the other 95% collapses into disorganized chaos. For the exam, you need to understand how this small domain acts as the glue for the entire project lifecycle. As we move forward, keep this breakdown in mind. Domain I, II, and the third are the what and who of construction management. Domain 4, our focus today, is the how and who says. It's about the authority structures that allow a project manager to actually do their job. If the governance is poor, the best contract in the world won't save a project from a lack of clear decision-making. To understand why this is so important, let's look at some sobering statistics regarding what happens when governance fails in the real world. What is the actual price tag of a project without a clear structure? Nobel laureate Oliver Williamson once described governance as an effort to craft order to mitigate conflict and realize mutual gains. In the high-stakes world of construction, crafting order isn't a luxury, it's a survival tactic. When we look at the data provided by the Construction Industry Institute and PMI research, the numbers are frankly staggering. Did you know that 33% of mega projects fail specifically because of communication issues? That is 1 out of every 3 massive projects failing, not because of bad concrete or engineering errors, but because people didn't know who to talk to or how to share information. Furthermore, more than 50% of all construction projects experience a significant negative impact on their triple constraint: time, cost, and scope. This is often the result of decision paralysis, where no one knows who has the authority to approve a change, so the project sits idle while costs mount. Perhaps the most shocking statistic is that only 5.4% of industrial projects actually meet best-in-class predictability for schedule and cost. That means nearly 95% of projects are struggling to hit their targets. Poor governance is the silent killer of project budgets. It manifests as reactive firefighting instead of proactive planning. When there is no clear framework, every small issue becomes a major crisis because the path to resolution is invisible. As we progress through this module, I want you to keep these statistics in mind. Every principle we discuss is a tool designed to pull your project out of that failing 50% and move it toward that elite 5.4% of predictable, successful projects. To do that, we first need to define exactly what we mean when we say governance. One of the most common mistakes in the industry, and a likely trap on the PMI-CP TM exam, is confusing governance with management. While they are closely linked, they are fundamentally different functions. Governance is defined as the process of decision-making within a framework to ensure coherence between the realization of project objectives and the resources used. In simpler terms, governance is about direction and oversight, while management is about execution and action. Let's break this down using the visual on this slide. Imagine a large bridge. The governance framework is the structure of the bridge itself, the pillars and the deck. It defines the path, sets the limits, and provides the authority. It tells you where you can go and who is allowed to drive. Management, on the other hand, is the traffic moving across the bridge. Management operates within the framework provided. While the project manager is responsible for day-to-day operations and delivering the project, the governance body, like a project board, defines the decision structure and sets the levels of authority. For example, a project manager manages the site team, management, but the governance structure determines if that project manager has the authority to approve a $500,000 change order, authority. If the project hits a major roadblock, the governance framework dictates which gate or board must be consulted to make a high-level decision. Understanding this distinction is vital. Governance sets the rules of the game, and management plays the game. Now let's look at the specific benefits your project gains when this relationship is handled correctly. If you are trying to convince a skeptical client or a distracted executive team why they need to invest time in a governance structure, this slide is your roadmap. The first and perhaps most critical benefit is the establishment of a single point of accountability. In massive megaprojects involving dozens of subcontractors and government agencies, confusion is the default state. Effective governance ensures that for every major deliverable, there is one person, and only one, where the buck stops. This eliminates the finger-pointing culture that often drains project morale. Secondly, good governance transforms your risk management. Instead of reacting to a crisis after it has already delayed the schedule, what we call firefighting, a governance framework provides the forms and reporting tools to identify early warning signs. It allows the team to develop proactive mitigation plans. This is supported by the third benefit, defined roles. When roles are transparent, every stakeholder knows exactly what is required of them and when. There is no ambiguity about who is responsible for safety inspections versus who is responsible for financial audits. Finally, governance facilitates transparent communication. It's not just about talking. It's about using high-quality management information, MI, and key performance indicators, KPIs, to ensure the right information reaches the right people at the right time. This isn't just status reporting, it's decision support reporting. When the project board looks at the data, they should see a clear line of sight to the project's health. By implementing these 4 pillars, you move away from chaos and toward a structured, predictable delivery environment. Next, let's look at the 5 core principles that guide this process. To build a governance structure that actually works, we follow 5 fundamental principles, largely based on the work of Hodgson. First, you must establish clear accountability. This means the project board is responsible for defining the desired outcomes, the what, while the project manager is responsible for defining how those tasks are delegated, the how. There should be no overlap or confusion between these two layers. The second principle is to identify key stakeholders early. However, there is a warning here. You must beware of too many cooks in the kitchen. Having an excessive number of stakeholders in the decision-making loop leads to decision paralysis. The goal is to identify those with genuine influence and interest, without slowing the project to a crawl. Third, you must implement systems and processes. This means having a robust project management information system, PMIS, and clear financial reporting tools. You cannot govern what you cannot measure. Fourth, you must monitor and report on a regular schedule. The goal here isn't just to look backward at what happened last month, but to identify early warning signs of future risks. If a supplier is late with one delivery, governance triggers a report to see if they are a risk for the entire phase. Finally, always focus on delivery. This is a crucial pro tip for the exam. Governance is not meant to be a bureaucratic hurdle. It should support the project's agility. If your governance structure makes it impossible to move dirt on the site, then the structure is broken. Governance should be the enabler of work, not the inhibitor. Now, let's look at how we put these principles into practice through best practices and stage gates. How do we ensure a project doesn't just drift into failure? We use a system of stage gates. Think of these as the security checkpoints of the project lifecycle. Best practices in governance dictate that a project must be divided into manageable stages. Between each stage, for example, between design and procurement, there is a gate. At each gate, there is an executive decision point. The governance board looks at the performance data and makes one of three choices: continue, proceed to the next stage, stop, cancel the project because it's no longer viable, or modify, change the scope or budget before moving on. This go-no-go approach is vital for construction. If you discover a massive site contamination issue during stage 1, you don't want to blindly proceed into stage 2, construction, without a major review at gate 1. This prevents what we call sunk cost fallacy, where projects keep spending money just because they've already spent so much. Beyond gates, best practices also include having a clear project definition from day 1, meaning everyone agrees on the scope, cost, and schedule. Furthermore, you need total visibility into performance. This means the project board isn't just taking the PM's word for it. They are looking at verified data through the PMIS. Rigorous communication and internal accountability ensure that if a stage is falling behind, it's identified at the gate, not 6 months later when the budget is gone. This structured approach ensures that the project remains aligned with the business case at every single step. Now, let's look at the 8 structural components that make up this entire governance engine. When you're asked to design or audit a governance structure, you should look for these 8 specific components. They function like the vital organs of the project. Component 1 is the governance framework itself, the overall hierarchy. Component 2 covers roles and responsibilities, ensuring we know who is doing what. Component 3 and 4 deal with the human and social aspect, stakeholder engagement, and the meetings or forums where decisions actually happen. The 5th component is communication and reporting, the lifeblood of information. Without accurate reports, the boards are flying blind. Component 6 is risk and issue management, which we've discussed as being a proactive necessity. Component 7 is assurance, which is often overlooked but is a favorite topic for the PMI-CP exam. Assurance is the independent verification, like an external audit, that the project is actually following the rules. Finally, Component 8 is project management control, which involves the specific tools and techniques used to keep the project on track. As a construction professional, you need to ensure all 8 of these are present and healthy. If you have great meetings, Component 4, but no independent assurance, Component 7, you might be making decisions based on sugar-coated data. If you have a framework, Component 1, but no defined roles, Component 2, you have an empty shell where no one takes action. In the next few slides, we are going to dive deeper into the most critical of these components, starting with the framework and the mega-project hierarchy. In a mega-project, the organizational chart can look like a labyrinth. A robust governance framework simplifies this into a clear hierarchy. At the very top, we have the project board. Their job is high-level oversight. They aren't worried about which brand of bricks is being used. They are worried about the project's strategic alignment and overall health. Below the main board, you will often find specialized sub-boards or authorities. For example, the finance board handles budget oversight and large-scale funding issues. The design authority provides engineering oversight to ensure the technical integrity of the build. The government group might provide stakeholder advice, especially in public-private partnerships, while the procurement board oversees massive contract awards. These specialized groups feed information up to the project board and provide guidance down to the next level, the project team and PMO, Project Management Office. The PMO is the engine room that supports the engineering and construction teams on the ground. This structure ensures that technical problems are solved by engineers, but financial problems are solved by the finance board. It prevents a bottleneck where the project manager is expected to be an expert in everything from structural load-bearing to international tax law. By separating these concerns, the project can move faster and with more specialized expertise. This hierarchy only works, however, if we know exactly who is responsible for what within those boxes. Let's look at the RACI matrix. The RACI matrix is arguably the most important tool in the project manager's governance toolkit. Its sole objective is to eliminate ambiguity. If two people think they are both in charge of a task, you have a conflict. If no one thinks they are in charge, the task doesn't get done. RACI stands for responsible, accountable, consulted, and informed. Let's define these carefully because the exam will test your understanding of the nuances. Responsible is the doer, the person or team performing the actual labor. Accountable is the most important role. This is the single person who is answerable for the success or failure of the work. Note the rule. You can have many people responsible, but only one person accountable. As the slide says, this is where the buck stops. Consulted stakeholders are those whose expertise is needed before or during the task. They have a two-way communication flow. Finally, informed stakeholders are kept up to date on progress, but aren't asked for input. This is a one-way communication flow. A classic mistake in construction is consulting too many people, which leads to those 33% communication failure rates we saw earlier. By establishing a single point of accountability at the project outset, you ensure that when a decision is needed at a gate, everyone knows exactly who needs to provide the answer. It creates a culture of ownership. Now that we have our roles, we need to decide how those people will actually meet and talk. Governance happens in rooms or virtual calls where stakeholders meet. Component 3 involves identifying both internal stakeholders, like your resource managers and team, and external stakeholders, like government regulators, contractors, and the general public. For the PMI-CP TM, pay close attention to board composition. A high-level board shouldn't just be important people. It must include specific expertise in finance, asset management, and project delivery. If your board doesn't understand how construction works, they cannot govern a construction project effectively. Component 4 focuses on the meetings and forums, where these stakeholders interact. The golden rule here is balance. If you have a meeting for every tiny detail, you will hit decision paralysis, where the project stops moving because everyone is always in a conference room. If you have too few meetings, you have a communication breakdown, where risks go unnoticed until it's too late. To prevent this, every single forum must have a formal terms of reference, or TOR. A TOR is the contract for the meeting. It must define the purpose. Is this meeting for sharing information or for making decisions? It must define the decision authority. What is this group allowed to approve? It should list the chair, the expert members, and the frequency of the meetings. If a meeting doesn't have a TOR, it shouldn't exist. This level of discipline ensures that time is used effectively and that the governance structure remains lean and delivery-focused. Next, let's look at how we protect the project through risk management and the 3 lines of defense. In the world of governance, no news is usually bad news. Effective governance relies on risk and issue management that focuses on early warning signs. For construction, this means looking specifically for things like frequent scope changes, incomplete design packages being issued to the field, procurement delays for long lead items, or a spike in minor safety incidents. These are the smoke that signals a future fire. This brings us to assurance, which is the 3rd line of defense. The first line of defense is operational management, the day-to-day controls the PM uses, but the governance structure requires something more: independent assurance. This means someone outside the project team, either an internal or external auditor, comes in to verify that the project is actually doing what it says it's doing. They check if the RACI is being followed, if the PMIS data is accurate, and if the gates are being respected. Think of assurance as a sanity check. It provides the project board with a level of confidence that isn't influenced by the project team's natural desire to report that everything is fine. By having these 3 lines of defense, the project protects its core objectives. It ensures that the skeleton of the project, the governance, is actually holding the weight of the work. As we wrap up this module, let's review the key takeaways you'll need for your exam. As you prepare for the PMI-CP TM exam, keep these key takeaways at the front of your mind. First, always remember the distinction. Governance is the framework and the authority, while management is the execution of the work. If a question asks who sets the authority levels, the answer is governance. Second, the single point of accountability is considered the holy grail of governance benefits. If a project is failing because of confusion, the solution is likely a clear accountability structure. You must also be fluent in the RACI matrix. Expect questions that test whether you know that only one person can be accountable, or whether a certain stakeholder should be consulted versus just informed. Understand the concept of stage gates as go, no-go decision points. These are the moments where the governance board exercises its power to continue, stop, or modify the project. Be aware of the risks of decision paralysis. It's a common pitfall when governance becomes too heavy or bureaucratic. Don't forget the role of assurance. It must be independent. An audit done by the project manager on their own work is not assurance. It must be separate from the project team. Finally, memorize that 33% statistic. It is a powerful reminder that communication is the primary driver of failure in mega projects. If you can master these concepts, you are well on your way to mastering the governance domain of the exam. Let's conclude with a final summary of why this all matters. To wrap up, let's return to our primary metaphor. Governance is the skeleton of your project. Just as a body cannot stand without a skeleton, a construction project cannot succeed without a governance framework. It is what aligns your high-level objectives with your limited resources and prevents the entire endeavor from collapsing under the weight of conflict and confusion. Building this skeleton requires a structured framework. It's not enough to just have meetings. You need formal boards, clear terms of reference, TOR, and strictly defined roles using tools like the RACI matrix. Furthermore, this skeleton needs nerves to carry information, which is why transparency through robust PMIs and reporting systems is non-negotiable. Without data, the skeleton is paralyzed. As the experts at KPMG noted, good governance gives boards a clear line of sight on project issues to make the right decisions at the right time. In the built environment, timing is everything. A decision made too late can cost millions in standing time for equipment and labor. By establishing appropriate governance structures, you give your project the best possible chance to be part of that elite 5.4% of successful, predictable projects. Have you ever spent weeks studying for a certification, only to sit down for the exam and realize you prioritized the wrong topics? It is a common pitfall for even the most experienced professionals. You might know how to run a construction site, but do you know how to pass the PMI-CP exam? This final session is designed to ensure that doesn't happen to you. We are diving into a strategic briefing that serves as your final checklist and roadmap for the PMI-CP certification. First, we will establish the ground rules for how this exam was built. Understanding the why behind the questions will change how you interpret them. Next, we will break down the mathematical weighting of the exam domains. Not all topics are created equal. Some carry the weight of half your score, while others are minor supporting players. Finally, we will look at the specific mindset you need to adopt to align your real-world experience with the expectations of the Project Management Institute. This matters because the construction industry is notoriously complex. Moving from a tactical, day-to-day site management role into a strategic, construction professional mindset requires a shift in perspective. Whether you are an engineer, a project manager, or a site supervisor. This briefing is the bridge between your technical knowledge and your professional certification. Now, let's begin by looking at the rigorous foundation upon which this entire exam is built: the job task analysis. Imagine you are building a high-rise. You wouldn't start pouring concrete without a geotechnical report and a verified structural design. The PMI-CP exam is built with that same level of rigor. A common concern for candidates is whether the exam questions are actually relevant to what happens on a real construction site. The answer lies in the job task analysis, or JTA. First, let's look at the process. The exam isn't written by academics in a vacuum. It starts with a global expert panel, real-world practitioners who define what it actually takes to succeed in our industry today. They use the JTA to measure knowledge based on 3 specific metrics: salience, or how much a piece of knowledge stands out; criticality, which is the risk involved if the task is done wrong; and frequency, or how often you actually perform the task in a construction role. This ensures that the exam evaluates the exact skills you need to function as a construction professional. Now, this matters for your study strategy because of the source authority. Every question is written and peer-reviewed by qualified construction professionals who also hold PMP certifications. This means when you read a question, you should hear the voice of a peer, not a textbook. If you find yourself overthinking a scenario, ask yourself, what would a seasoned, certified PM do in this exact situation to minimize risk? This foundation of real-world relevance is what gives the PMI-CP its value in the marketplace. With the foundation set, let's look at how these tasks are weighted across the different exam domains. If you had only 10 hours left to study, where would you spend them? Many students make the mistake of spreading their time evenly across all chapters, but as you can see from our strategic priorities, that is a losing formula. The PMI-CP exam is divided into 4 distinct domains, each with a very different impact on your final score. First and most importantly, we have contracts management, which makes up a staggering 50% of the exam. This is the make or break zone. If you are a master of contracts, you are already halfway to your certification. Next, we have stakeholder engagement at 30%. In construction, we know that people and relationships can derail a project faster than technical errors, and the exam weighting reflects this reality. Following these are strategy and scope at 15%, and finally, project governance at a focused 5%. This matters because your study schedule should be a reflection of these percentages. Our strategic insight for you is simple. Align your study time with these weights. If you are spending days memorizing governance frameworks but only hours on contract law and risk allocation, you are misallocating your brain capital. You need to prioritize domain 1 above all else. To help you do that, let's take a closer look at why contracts management is considered the critical path of this exam. Think of domain I, contracts management, as the foundation and framing of your exam success. Why does PMI place so much weight on this? Because in the world of construction, the contract is the rule book for everything from payment to dispute resolution. If you don't understand the contract, you can't manage the project effectively. This domain represents the highest volume of questions you will encounter. Let's talk about the stakes. Success in this domain virtually guarantees you a passing baseline. It is almost impossible to fail the overall exam if you perform exceptionally well here, whereas you could get a perfect score in governance and still fail if you miss the mark on contracts. Your focus during revision should be on the entire contract lifecycle, from procurement and bidding to execution, and finally, closeout. You must understand risk allocation, who bears the burden when things go wrong, and the specific legal obligations that bind the owner, the contractor, and the subcontractors. Now, this matters because for many technical professionals, the legal side of construction feels less intuitive than the building side. However, the exam requires you to think like a contract administrator. When a question asks about a change order or a delay claim, your first thought should be, what does the contract say? We cannot emphasize this enough. Prioritize this domain above all others. Once you have secured this 50%, the next 30% comes down to the people involved in the project. Have you ever had a project go perfectly on paper, only to have a local community group or a difficult client shut down your site? We often say that we don't just build structures, we manage expectations. This is why stakeholder engagement is your secondary objective, making up 30% of the exam. This domain focuses on the human element. It's about more than just being nice. You will be tested on your ability to manage complex relationships, streamline communication across diverse teams, and professionally handle objections. In construction, stakeholders range from government inspectors and environmental groups to the laborers on the ground and the C-suite executives funding the project. The exam reflects the reality that construction is, at its core, a people business. Here's the strategic reality you need to remember. When you combine contracts and stakeholder engagement, you are looking at 80% of your total exam score. If you master these two areas, you have effectively passed the exam. This matters because it allows you to be surgical with your preparation. You aren't just studying project management. You are studying the intersection of legal frameworks and human behavior. Next, let's look at the remaining 20% that rounds out your professional profile: strategy and governance. And while the big two domains cover 80% of the exam, a true construction professional must also master the mechanics of strategy and governance. These are the supporting objectives that ensure a project doesn't just finish, but finishes for the right reasons. Domain third, strategy and scope, represents 15% of your score. First, let's look at strategy and scope. This is about alignment. Is the project actually delivering what the organization needs? You'll need to focus on strictly defining the work scope, avoiding the scope creep that kills construction margins, and ensuring that every task performed on site aligns with the high-level organizational goals. Next, we have project governance at 5%. Don't let the small percentage fool you. This is about the rules of engagement. It covers oversight mechanisms, compliance with regulations, and the decision-making frameworks that determine how a project is steered. This matters because these domains are often where the gap exists between a project manager and a construction executive. Even though they are lower in volume than the contracts domain, they are essential for a complete passing score. Think of these as the guardrails that keep your contract and your stakeholders on the right path. Now that we've covered what is on the exam, let's talk about how the questions are framed across different project methodologies. In the past, construction was seen as a purely waterfall industry. You plan everything, then you build it. But the modern construction professional knows that the world is changing. The PMI-CP exam uses what we call the value delivery spectrum. This means you won't just see questions about traditional linear projects. First, you have predictive or waterfall methodologies. This is the traditional approach where scope, time, and cost are determined early. Next, there is the adaptive or agile approach, which is more common in software but is finding its way into construction through lean principles and iterative design. Finally, there is the hybrid approach, perhaps the most common in modern construction, which blends the two. The core rule for the exam is that these approaches are not isolated to any particular domain. You might get a contracts question that is set in a predictive environment, or a stakeholder question that occurs during an adaptive phase of a project. This matters because you must be prepared to shift your mindset. You need to be able to move between rigid predictive planning and the flexible, adaptive change management required when project conditions shift. Don't get stuck in one way of working. Now let's clear up a major point of confusion: how this exam differs from the standard PMP. Many of you may already hold a PMP certification or have studied the PMBOK guide. While that is a fantastic foundation, here is a critical warning: the PMI-CP is a different beast entirely. You cannot simply PMP your way through this exam. The distinction is in the source of the material. The PMBOK guide is a general framework for all project management. In contrast, the PMI-CP is derived from that specific construction job task analysis we discussed earlier. It is not bound by general PM theory. It is bound by the actual practice of construction. While there are commonalities, the exam focuses heavily on construction-specific nuances, things like environmental permits, site safety, and construction-specific contract law that you won't find in a general PM guide. This matters because standard PMP logic can sometimes lead you to the wrong answer in a construction context. For example, in a software project, you might fail fast, but in construction, failing can be catastrophic. You must rely on the exam content outline, ECO, and the specific construction references provided. Think like a builder, not just a manager. With that distinction in mind, let's look at how to focus your final hours of study. We are nearing the finish line, so let's talk about execution. How do you take all this information and turn it into a passing score? It comes down to a few key strategic pillars. First, and I will say it again because it is that important, contracts management is the anchor of your exam. If you are not confident there, you are not ready. Next, let's talk about the nature of the questions. They are highly situational. You won't just be asked for definitions, you will be placed in active construction settings. When you encounter these, use the best answer approach. Select the option that maximizes three things: safety, quality, and contractual integrity. If an answer choice suggests cutting a corner on a contract to save a relationship, it is likely wrong. We follow the industry standards here. Finally, let's look at your clock. For your remaining study hours, dedicate exactly 50% of them to Domain I. This is the most efficient use of your time. Remember, the authors of these questions are your peers, PMP certified construction pros. When you read a question, don't look for a trick. Look for the most professional, high-integrity path forward. Now, let's go through your final checklist before you head to the testing center. You've put in the work, and now it's time to verify your readiness. Before you sit for that exam, run through this final checklist. First, have you reviewed the contracts domain until you can explain risk allocation in your sleep? That 50% is your safety net. Second, can you navigate the complexities of stakeholder objections and communication? That's your next 30%. Next, check your flexibility. Are you ready for questions that jump from a rigid waterfall schedule to an adaptive change process? Remember the value delivery spectrum. But most importantly, check your mindset. When you walk into that exam room, you aren't a student. You are a construction professional. Every answer you provide should reflect the expertise, ethics, and strategic thinking of a leader in our industry. This matters because the PMI-CP is more than just a piece of paper. It's a validation of your ability to handle the toughest projects in the built environment. You have the knowledge, you have the weighting, you have the strategy. Now, there is nothing left to do but execute. Good luck. We look forward to seeing you join the ranks of certified PMI construction professionals.